various speakers talking about tools. So first up, we're going to have Willie Marcel. And Willie,
Hello.
feel free to take it away.
Thank you, Jess. Hello, I'm going to talk today about the latest feature that we introduced in USMChat that allows us to monitor the features that we care about. First, introduction about me. I am a contributor of OpenStreetMap since 2010, and I created OSMChat in 2015 and have been maintaining it for some years with the support from Mabox. But right now, I am a software engineer at Development Seed. So, to those that who don't know what is OSMChat, it's basically a database of change sets from OpenStreetMap, and we allow to search change sets using a huge like many options of metadata. We store all the metadata about the change set, and also we store some flags about each change set that makes it easier to us to identify some possible issues and also to prioritize some change sets to be reviewed. And also we have a nice map visualization of the change set that allow us to understand better what is happening on the change set. So it's basically the database that we can search, and we can have a lot of information about the change set and visualize it. Some mappers, most mappers, I think, they care about some part of the world, like the region where they live, or some other region that they have interest. And it's very common that some mappers tries to monitor some of those regions that they care about. But we have also some mappers that care about some specific type of features, or some companies that are interested in some type of features on map, for example, bicycle parking or bicycle rental stations or cafes or any other type of features in your map. And users always asked us, like, if they could use OSMChat to find change sets that affect some of those features. And it was always a challenge to make it possible, because we don't have a database of all the features and all the history of the features in OpenStreetMap. So with the support of Wikimedia Italia, the development seed got some funding, and we could work on that challenge and add that capability to OSMChat to search change sets by some OSM tags. So you could find the edits that affect some type of features. Like, for example, you could search for shop equals bicycle, or for highway equals star. So basically, let me open here under that window. You can go to the filters. Let me reset it. You can go to the filters, and here you can search by a combination of key values and find something like highway primary, and then you can search change sets that affects that text. So I will show some of the filters that I have created, and demonstrate what that new capability on OSMChat opens for us. So, for example, here we have in Curitiba, that is a city in Brazil, the addresses were imported from a open data set, and then I think that it's interesting to monitor the changes on the addresses, because we had some source and we imported from a source, and it's interesting that we don't lose that information from time to time. So, for example, I forgot what was the change set exactly, but let me check in here. Let's try that. And we can visualize here the entire change set, but we can also see some of the tag chains, and we can see here that we had an address house number tag deleted, so we can check it here. But on that case, actually, like, it was a duplication because that address was present on another feature. I think the same here, but yes, for example, yesterday when I was preparing the presentation, I found a case of it was on that chat that deleted an address from on that node. We lose this address, and it was not inserted in any other feature, so I could revert that that node deletion, so we recover an address that was lost. To those that are interested in Wikipedia or Wikidata tags, we can also do that. Like, for example, here I created a Wikipedia equals star in New York. Actually, Wikidata, it's correct, the title here. So we can see the change in the Wikidata Wikipedia tags, and then you can like verify if that value is correct or not, and it's another possibility to check. And for example, in that case, someone added a Wikidata tag to this, I think, a building. And other interesting thing here in the city where I live, I am mapping the boundaries of any of the suburbs or neighborhoods. So yes, I was interested in checking if, like, we don't lose that information, like that users don't update the suburbs with incorrect information. So I can do that checking here as well. Like, for example, in that case, it's okay. It was a place square that was deleted because the user updated to use the leisure park tag. So yes, I think this new capability opens a lot of possibilities to the users to improve the validation of the features that they care about. And yes, the company where I work from, the Development Seed, is looking for the organizations that are interested in funding more improvements to SMCHA. We had some some problems in the performance of the database recently that caused some days without OSM chat being live, but we have recovered it, and we are planning more maintenance and more development for it. Thank you very much, and I let me know if you have some questions.
Great. Thanks, Willie. We probably have time for just one question on this one, but I will pop it up here on the screen. So when you use multiple tags, it looks like OSM CHA filters on all of them. And can you also specify to filter on any tags? Or
yes, right now the logic is to use int only, but yes, it should be. I think it should be useful to support also the OR option.
Great, thank you, Willie. If there's any other questions, feel free to ask them in the chat. Willie can answer through the chat, and if we have more time at the end of the session, then we can bring on all the speakers and just answer questions for any of the presentations in this block. So thank you, Willie. Okay, next up we have Chad Blevins. Floor is yours.
Hi, everyone. I'm Chad Blevins, and I work for CART, a small geospatial company based in Grand Junction, Colorado, although I'm in Virginia, just outside of DC. And I'm going to walk you through Micro. It's a CART tool designed to take a sustainable approach to OpenStreetMap community mapping through a micropayment system. So as we all know, local communities have firsthand knowledge of the places that they live, but they may not have the time or resources necessary to contribute to OpenStreetMap. Mapping requires expensive hardware, reliable internet, smartphones, and free time. And these are things that not everyone has access to, or they could scale their existing mapping with better tools and resources. So how can we support a global community of mappers who may need just basic resources to map? Welcome to Micro. This is the tool that we're developing, a micropayment system that allows mappers to get paid for their contributions. It's focused on helping local mappers be compensated for doing work that isn't always fun, but it's necessary for making great maps. So how does it work? It works by inviting trusted users, local mappers, or even opening a campaign to all mappers to join a specific project. Once users register for the Micro platform, they do this through their OpenStreetMap account, and then they connect their payment information. They then go through a quick training and pass a basic test to get approved into the system. And once approved, they join a specific campaign and begin making edits. These mapping campaigns include, projects focused on improving roadways, capturing specific points of interest, or even validating the work of other mappers. And finally, mappers get paid through Payoneer on a predetermined rate and schedule. Currently, Micro is integrated into the tasking manager, and we're testing other custom applications integration, including Map Roulette and a couple different mobile editors. So the thought is that we can get this to work, synonymously on whichever type of editing platform the community prefers using. Projects are monitored through a dashboard that tracks completion rates, mapper contributions, and payouts, and also allows for direct communication between mappers and project managers. Each contribution will earn a predetermined payment, allowing users to contribute as much or as little as necessary to complete their work. And then payments can be scaled depending on the complexity of edits or difficulty of capturing specific features. So if you're looking for a way to scale local contributions to the map, particularly in less developed places in the world, please reach out. I welcome the conversation. So I think we have time for a few questions, and Thank you.
Thanks, Chad. Any questions for Chad in the chat here? There's a bit of a delay, so it might take a second to get those.
Okay.
And if anyone doesn't have any questions right now or thinks of them later, we definitely will have time at the end. And I see there are some questions for Willie still in the chat. He might jump back in there, back into Hopin to answer those, or we can save them till the end. Okay, Chad, I'm just gonna let you answer questions that come up in the chat. Oh, got one. The delay is definitely gonna be a little bit of a challenge. So let's, if you have questions throughout the presentation, please just ask them right away. That'll help us here at the end. But the question we got was from Jacob Hall. What areas are you targeting to start trying out this program?
Yeah, let me just make sure I'm not on mute. Yeah, we're targeting primarily work in developing countries where, you know, mappers have less resources to complete these projects. So we've been testing some things out in Africa right now that I know of, and I think there's a project in somewhere in South Asia. I can't remember specifically. But yeah, if you have an idea or a need, we'd love to try and test it out with you.
Great, thanks, Chad.
Mm-hmm.
Diane had a similar question. But yeah, we'll just we'll end it there for yours. So thank you, Chad, and feel free to hop back into Hopin.
All right, thanks everyone.
Okay, next up, we have Jennings Anderson and Mike Jeff. And I will give you the floor.
Great. So I don't see how I'm advancing these. So if others have control, great.
Yep, I've got it.
Awesome, thanks. So I'm Mike Jeffy. I'm at AWS. I'm off mute. Happy Saturday. I'm on the open data team at AWS, where I focus on geospatial data sets and the larger community. I'm joined by Jennings Anderson from Meta, who's worked with Daylight for some time. As part of my work, I talk to customers, including many here today, about making large archives of geospatial data publicly available on AWS. And through some of this work, we've made over 100 petabytes of high-value cloud optimized data for public use. I'm here to talk about Daylight. And so Daylight map distribution, it's a complete distribution of global OSM data that includes quality and consistency checks with from different Daylight mapping partners to create a free, stable, and easy to use street scale global map. Daylight was first announced in March 2020. I've provided a little timeline here with a version in the standard Planet PDF file, PBF file format. This has since evolved into a collaborative effort to include coastline boundaries and building footprints for Microsoft and Esri. Now with version 1.9, they introduced something called the analysis ready format, which are Parquet files that make it easy to load the data into Athena. This columnar storage format of Parquet has different optimizations that allows for fast querying and retrieval of the data, which we'll get to in Jennings' demo. So next. So like, it's kind of good to look at this from sort of the pre and post perspective. So this is a sort of typical OSM workflow, or people are very familiar with working with this data. So users go out and look for the source of the data that they grabbed, either OSM OpenStreetMap.org or Overpass or some other site. They're downloading the data, they're pre-processing it to sort of a desired state, and they're converting the data to an analysis ready format. And a lot here is where sort of like it gets tricky, because we're taking geometry in different natives and primitives, and we're sort of doing things to make it more suitable for the downstream analysis that we want to do. And then, of course, there's the analysis part that usually runs in different GIS environments. So cue next slide. So with Daylight, what we're trying to do here is remove that part of the pre-processing step and have it immediately available as an analysis ready. So what does this mean? It means that the data are grabbed from source, they're loaded into tables, and they're queryable using a tool like Amazon Athena, which can run serverless SQL at global scale. And so this sort of removes a lot of that undifferentiated heavy lifting that takes a lot of time. And what we're trying to do is give people back that time to focus on the downstream analysis or ML or whatever it is that they want to be focusing on. So this is kind of the part that we feel is really exciting here. So just next slide. Just a quick look at the Daylight schema. Daylight data. Oh, I had it on the first slide, but I didn't realize it's not on this slide. We have it on the Registry of Open Data on AWS. So if you go to that page, that URL, which I'm happy to pass later, you could see the data set, and there's a tutorial for loading the data into Athena. This is the schema, kind of goes through more or less what it looks like when you're interacting with the data. The key part is that there is like well-known text representation of the geometry, so you can do this kind of SQL querying and pull data down, but use the geometry to filter the data. And so this is just a quick example of querying highways in Puerto Rico, and it takes seconds to pull data and export it to something like download as a CSV, which you can load in QGIS or any other environment. And yeah, now Jennings is going to show some of the stuff that you can do.
Fantastic. Okay. Can everyone hear me? Yeah, it looks like I'm unmuted. Excellent. Thanks, Mike. So we'll pop out of this demo here. And here is that page. This is and also I saw that Jacob posted the link here in the comments. This is the Registry of Open Data on AWS / Daylight-OSM. And so here we have links to like this tutorial, loading Daylight map distribution, which you just need to go to pull the, just all just kind of copy and paste examples here to get up and running. So as an example, if we go to this loading Daylight map distribution link, we get this one query. The advantage of having Daylight as part of the Open Data Registry is then Amazon and Meta are holding all the data and all the costs associated with holding the data, and all you do is run this little query in your Athena console, and which was right here. So you just have to have an AWS account. Go ahead and paste that query in, run it, and that will create the tables on your account that are pointing to the data in the on the other on the Registry of Open Data buckets. So we do that. We set up this table. This usually runs very quickly, and then we can start querying. So I ran an example. I got a little nervous about a live demo, so I pre-ran these earlier. But you can see in this one example, this first query example, it ran in 15 seconds, and it only had to scan 11 gigabytes of data, and that's because we have the columnar storage for the Parquet files. And so what this query is doing, and then this is all just pretty standard SQL. So no new languages here per se for yet another analysis language for OSM, but rather we get to access all of OSM, all Daylight OSM here just with SQL. I'm querying here for the total millions of kilometers of the highway features in OSM based on their value of their highway tag. So we see this result here. We have residential, highway equals residential. Looks like there's 17.6 million kilometers of highway equals residential in Daylight OSM. And then we can go down here, track unclassified tertiary. So point here is to show that we can just query all of OSM. This is planet-wide scale in what looks like about 14 and a half seconds, scanning an extraordinarily relative, small amount of data compared to the whole planet, which that equates to being very, very cheap. I think this would be less than a cent in cost when querying this. So here's a first example, and then let's dive into something a little bit more interesting here. In this case, this next query, we can also join this to say let me make that a little bigger, sorry. We can also join our daylight data to say the change set table. And on the change set table, we can look for comments in the change sets. Like in this case, we'll use hot OSM, and we'll query for all the data after 2015, and we'll count the total amount of linear meters of length of highways, and then we can also count building objects. And if we do that, we can then load it into an analysis environment, and we can see something like this, showing the history of when buildings and, sorry, I know it's probably really small, when buildings and highways were added to OSM. So this is just another example of another way we can get the data out and do quick we've done now all our big processing in Athena, and now we're just bringing down the data to visualize here in another environment. So just really trying to make that OSM data analysis process so much easier. Jess, how am I doing on time? Do you want me to wrap up?
You got a couple minutes.
Okay, great. I will show one more example here. In this example, I wanted to look at what are some of the top features mapped in OSM on amenities, and globally that tends to be places of worship and restaurants and cafes. So I had a question there. Well, can we easily find areas in the world where there's more restaurants than places of worship, and vice versa? So the analysis ready Parquet files, each feature also includes the quad key, the Bing tile quad key for where that feature exists. So that's a really kind of cheap way to do spatial aggregation. So in this case, I'm going to grab the Bing tile polygon associated with each of these features, and then we'll count if it's a place of worship or a restaurant or cafe. And so now when we run this again, takes about 16 seconds, and it's going to do this for zoom level 8 across the entire world. And what we get back is a geometry and a count of churches and restaurants. And so if I take that now and load that into QGIS, we can now create something like this. There we go. And in this case, we're looking at the ratio there. And so anywhere in red, we see more, significantly more restaurants than places of worship and churches. And anywhere in blue, actually, we have more places of worship than restaurants or cafes. So a little bit of a contrived example, but just something to show that we're doing global scale, analysis of all of OSM data here, and it ran remarkably. That took 16 seconds to get this CSV, and then I just dropped it right into QGIS, and we have an output. So yeah, okay, and we have time for a question or two, Jess.
We do. So we have one question right here in the queue. So is it possible to predict how much a query will cost?
The cool thing about Athena is that you are paying for the amount of data that's scanned. So you can have a remarkably complex query, but it's only going to charge you for the amount of data that's actually read. And so when we have, so that's one way we can predict it. We can kind of predict how much data is going to be read, not necessarily any other attributes of the query. So knowing that the whole data set, if you query everything, is like a terabyte, then when we're only looking at specific columns, that's going to be obviously much smaller. So for example, the more kind of filtered you make your query, the less data it will scan. So I don't think there's a way to necessarily predict exactly how much that will cost, but I kind of always start with like putting some limits and stuff in there and seeing how much data it is scanning, and then kind of scaling up from there. I don't know, do you have anything else to add to that one, Mike?
I was just going to say it might sort of result in a pre-optimization on the query to limit, where you're going to pull data from. Like if you want to do it sort of geographically or do it by like a certain amenity type. So could sort of change the way we start to interact with OSM data, which is good because we're pulling data quicker and cheaper. So I think that this is a positive outcome. I don't have anything to add about the Athena part, just that everything you said was correct about the cost. It doesn't keep running in the background as well. It's serverless, so it's not like it stays on. It's only charging when you're actually doing something.
Great. Well, thank you. I do see other questions rolling in, but stick around and we can answer those at the end. Thank you for your presentation. And next
Thank
up
you all.
is going to be Lisa. Lisa, you are on mute. There we go. And if we can get your presentation.
Can you see that?
No.
Okay. Let's see. Present. Screen. Oh. Let me try this again.
And while we're waiting, I do realize that there is both a Q&A and a chat feature on the stage. It's easiest if you can ask your questions in the chat. That makes it possible for us to see it backstage. So 1 minute, we're gonna get Lisa's loaded up, and I'll be right back. Okay, great. Thanks everyone for your patience. Okay, Lisa, looks like you're ready to go.
All right. Can you see me now?
Can see you in your screen, so thank you.
Sorry about that.
Not a problem. Take it away.
So, thanks for taking an interest in how robotics uses OSM in transforming visual data into meaningful maps. Lisa McCune-Knoll, and I'm Senior Quality Analyst and Cartographer with Robotics by Michelin. And I'm going to be going through some of these slides fairly quickly. This is just an overview of how we're using OSM in our processes. So robotics provides two solutions for real-world problems utilizing OSM data. So to the left in these images is roadway. This is our typical city street seen in our AI-driven road condition assessment platform. So municipalities can assess their roads as far as the pavement condition, whether they have a lot of potholes, a lot of cracking, etc. On the right, Agile Mapper is our asset mapping platform. So typical city sidewalk with all sorts of assets that need to be mapped, things like ADA warning pads, fire hydrants, signage, etc. So we have 6 roadway processes that use OSM directly, plus Agile Mapper itself. So these are map submission, where we get maps from clients or develop maps for clients and blueprint those maps. And then we use routing software to collect data, to create routes to collect the data. And then there's a process called point reassignment, where we clean up that data and make it look presentable to the client. And then Agile Mapper itself. So for map submission, we can accept all kinds of files, KMLs, shape files, whatever a client may have to create the map of their jurisdiction. And we consult with the client on what kind of roads they do want and don't want. So if they don't want alleys, if they don't want driveways, obviously that's not their jurisdiction. Also things like interstate and federal roads, county and parish roads, that kind of thing, that is not their responsibility. So we can customize that map to their needs. Even if they don't have a map, we can use any kind of tourist map, placemat maps, the kind of thing that a local print shop would create. We can use that to create their map. So we import those into our blueprinting process, which uses OSM. And if they have a shapefile or any other type of map file, it's an automatic process. It automatically selects the road segments that are needed, and we create the map straight from that. If they don't have a map of their own, we actually use geojson.io with an OSM base map and trace the jurisdiction boundary and select all the necessary road segments within that boundary to create the blueprinted map to work with. And if there's a discrepancy, we will actually go in and update OSM ourselves. We edit OpenStreetMap and accurately portray what we need to, and we're constantly trying to make improvements to OSM. We follow all OSM guidelines, and so we are giving back in that sense to improve OSM in the process. So here's an example. Cul-de-sacs are always fun. Adding in the little point feature for the turning circle. A lot of times these are missing from jurisdiction maps that we get. They're portrayed differently, maybe as an actual line feature rather than a point feature. So that's something that we would edit. Once our blueprint is complete, then we go in and route. We have to create the routes for drivers to collect the road data. So we use Ride with GPS, also using an OSM base, and we create turn-by-turn collection routes for the project. And this can be customized to suit the client's needs. Here's an example of projects, and each individual route is present. And you can see that we use OSM as our base and develop a nice routing system that then we can use in our own app for routing, RoadNav. This gives turn-by-turn directions, so the driver can collect their data using the RoadSense app, which collects out of the windshield, straight from the smartphone, road data that then our artificial intelligence will analyze and pick out things like cracking, potholes, rutting, that kind of thing. So we collect with the smartphone and use the turn-by-turn navigation, upload the data, and then our platform, Roadway, can display that data, and clients can use this, manipulate it, they can share it, and it's all presented in a nice format. They don't need a GPS or a GIS. If they don't have one, they can use this platform. They can also import from Roadway. So one of the processes before it gets to that nice presentation stage is point reassignment, where this is where we clean up the data. With routing, a lot of times we have to drive the same road multiple times. And so we want to use the best imagery or the best route that we have, the best data that we have. And in some cases, GPS is not at its best, shall we say. And you can see in this case that the GPS drift is quite significant. This happens a lot in large cities like Chicago and London, where there's tall buildings and a lot of reflection going on. So we try in the upper images, it shows all passes. So because of the routing, we have to collect many areas over and over again to get all the details. But we want to select the road pass that is closest to the road segments on OSM and has the best, most efficient data there. So in the bottom images, you can see that's what we end up with. Now, these are the worst cases. In the best cases, our data is spot on. The GPS is perfect. There's no drift, and everything is beautiful. So we present that data on the cloud-based system. This can be manipulated by the client. It can be shared by the client to whoever they need to share it with. And data can be downloaded from this as well and imported into any GIS system. So just a little more detail on this. This actually shows our 1 to 5 rating system for potholes and surface distresses. This lets municipalities know where they have to target their funding as far as road maintenance. And finally, AgileMapper is a complete asset mapping platform. We have an app and a platform that creates a mapped image library for any type of feature. And this allows you to collect any imagery data, also import imagery and video data, attribute it, document it, track changes over time. It also tags automatically. So whatever type of feature, municipal utilities, transportation features, everything from cafes to electric scooter stands, park signs, trees, whatever you want to collect. Agile Mapper can do it for you. Again, you can track all this, again, using OSM as a base map. This also works in conjunction with any GIS. It can import video and images from any geolocated device and adds those additional data tags. And so OSM is integral to both Agile Mapper and Roadway and enables robotics to transform visual data into meaningful maps. Thanks a lot. And if there's any questions, you can either hit me up in the chat. I'm on OSM Slack, LinkedIn. My email is there. And thanks a lot.
Thanks, Lisa. We're a bit past time, so won't be able to answer any questions live on screen, or at least right now. We'll circle back at the end, or you can tackle those in the chat. Thanks again. Next up, we have Albert. Will be presenting mapillary missions. Go ahead.
Awesome. Hi, everyone. My name is Albert Bautista. I'm from the Open Community Mapping at Meta. And I'll be presenting Mapillary Missions United States Edition. All right. So before I kind of dive into that, I wanted to talk about what is Mapillary Missions. Well, Mapillary Missions is a feature in our iOS apps that draws attentions to busier areas of the city and towns that might require imagery updates or doesn't have imagery. Mapillary Missions helps with this by creating grids around commercial areas and populated locations. Here's an example. We have the grid view and, of course, our list view. Here's another example of a less busier area. Each grid area represents a mission where imagery should be collected. Each mission has a target number of images to be collected, and the mission will be marked as completed once you capture required images in the mission. So let's take a look at the GIF here. How do I start to capture imagery with Mapillary Missions? So pretty simple. Let's kind of wait out for this GIF to restart. Go to the missions view, select the mission, capture the images within the area. As you see here, it's capturing images. And then once you finish capturing images or the required amount of images, you upload those images and bam, you should be able to upload all those images and complete the mission. So what is Mapillary Missions Challenges? Well, in August, over the summer, we launched our first challenge in Japan. It's basically a gamification of the mission feature, where we gathered these missions and created into challenges where you earn prizes and compete on a leadership board. And this time around, we're bringing it to the US. Starting today, we are launching missions for the US, where we are replicating the success in Japan, where we're trying to collect imagery in different parts of the US, all over the US, and compete for certain prizes. So as I said, we're launching US missions, Mapillary Missions, starting November 12th and finishing on December 12th. Final scores will be reviewed in the third week of December and announced in our different Mapillary social channels. So please do watch out and follow our different social channels. The official register site will be posted on our Mapillary blog. So how do you participate? As I mentioned, we will have our register your interest on our Mapillary blog. Of course, it'll be available for our iOS users. You could browse your missions in your area by the Mapillary Missions tab. And you could tap the missions that are associated to the goal associated with it. And as I showed you earlier, it's basically completing a mission in an area, start to capture, capture the required numbers of images by walking, driving, or cycling through a path, road, an emission area, and then uploading them to be recognized to complete a mission. You could, as I said, there's a leaderboard. So, and there's a bunch of prizes to win through. So, the more you finish missions, the more you get of a prize. So, we do have a leaderboard that we update every Friday throughout the leadership challenge. And if you have any questions about the challenge, make sure to reach out to support@mapillary.zendesk.com. Just things to note as this is going to be a competition. Do follow and support. If you need, reach out for support, as I mentioned at the email that I provided. But there are also different types of issues that you may fall through with different multiple accounts. There are these different scenarios that may happen if you're very competitive. I could You could see it down here, but don't threat. We are here to help out, and of course, all of your progress and your scoring will be recorded in our servers. And if you do have more issues about that, you can definitely reach out to me, or to our team, or through our email listing. Um, Again, please do check out if you have any questions or so. So now let's talk about prizes. So for participating and completing a mission, you would get a limited edition shirt that may come in white or oatmeal. Oatmeal is an interesting color, but definitely something that would be stylish for you to wear. If you are the third person to complete the most missions, you would get this limited edition tote. In second placer will receive this limited edition crew neck sweatshirt. And in first place, if you are the most in the US to collect and complete the most number of missions, you will be receiving a GoPro Max 360 action camera. Um, so please, these are great prizes for anyone who wants to join. So again, the challenge will start on November 12th and finish on December 12th. Final scores will be reviewed in the third week of December and announced on our Mapillary blog and other social channels. Please do register your intent, and we will announce all on our social channels of how to register on the event. This is a greater opportunity to not only win swag, but as well as to contribute to open data. So yeah, thank you very much. This is my first presentation.
Thanks, Albert. Just while we're on the subject, one quick question was if you could post the interest registration link in the chat later on.
Yeah, definitely. We're going to be following through later after this presentation.
Great. Thanks, Albert. And so Albert actually has another presentation on a different subject.
Yes.
So plenty of time to ask Albert questions. Feel free to continue asking questions in the chat about either of them. And then hopefully we'll have time to ask once this one's done. Go ahead.
So Jess, should I just move to the next presentation, or should we do questions now?
Feel free to do your second presentation, and then we can just do questions all together.
Okay, for sure. Thank you. Okay, and I think I could stop sharing, right? And I could just use the one on on the studio. I'm not sure.
Yeah, apologies, Albert. Yeah, your second presentation is loaded on Hopin right now.
Okay, so I could stop sharing. Okay.
Yes.
Let me do that. All right, everyone. This is my second presentation. And again, let me introduce myself. My name is Albert Bautista. I'm with the Open Community Mapping team at Meta, and I support different projects like Mapillary. And I wanted to present the second presentation on making street-level imagery available as open data with Mapillary. Mapillary is the street-level imagery platform that scales and automates mapping. Mapillary is a collaborative street-level imagery platform that lets anyone access the data that they need for making better maps. I believe that street level imagery could be and should be open data, as this body of images and data can be used to validate existing maps and update and improve any kind of data, any kind of maps data for any type of use cases. What's great about this is if you're utilizing Mapillary is that it holds a Creative Commons license, which allows anyone to utilize it. Um, which you could see here, many organizations utilize, such as my company, American Red Cross, the World Bank, and other institutions above and beyond. We cover around the world and have contributed around the world, which is great. And with our technology that we provide in Mapillary, we respect so many things, from its privacy by blurring sensitive information, our computer algorithms, and our computer vision technology gets a lot of lots of information that is useful from our geolocation of traffic signs, different assets like street level assets, and technologies that would really help to get the best level of detail that would be useful for a lot of use cases. And I'm slowly just going through this presentation as there's a lot of information. But just remember, I'm here as a resource, and there's a lot of information on our different social sites, and of course on mapillary.com. And essentially, all of this use cases that we have on Mapillary comes to a lot of useful information for different departments and agencies around the world. With the technology, it will help support different departments to move faster, to support a lot of their use cases of inventory, making things simpler for them, and definitely making more progress in terms of their use cases. We have seen it in inventory use cases for Vermont and Department of Transportation. We should have seen research use cases in Saint Martin, and a lot of other groups who have seen quite benefits with utilizing Mapillary. It's a really simple process, to honestly, to just get yourself into getting open data and start using Mapillary. You could bike, you could use your car, you could use any type of device that has a camera, a smartphone, action cam, and it's easy to capture street level imagery and upload and start contributing. As I said, any camera, anywhere, smartphone, action camera, or dash cam, or a 360 cam. So it's basically imagery in, maps data out, and you could already start contributing, and open data could come. All open data can come out from it and start improving maps data for any use case. So how do you get started? It's essentially downloading the app, no sign up needed. Get outside and get a good GPS location and service. And definitely sign up through mapillary.com mobiles app. Of course, when you start capturing, ensure that you abide by local laws if you're in a car. Watch your step when you're walking, and of course, be cautious when you're utilizing a bike. This is more of direction with the mobile. You have the red button to start, A for automatic capture when you start moving, and time and distance based. And this is just for some of more of the advanced tooling. And I'm kind of breezing through a little bit with the time constraints, but definitely if you have any questions, you could definitely contact me and our team. We're very happy to lead you through for more intermediate or advanced steps. But I just wanted to breeze through for all the tools and all the available things that you could utilize when working with Mapillary. We have different tools that to upload just beyond if you are quite the enthusiast with Mapillary loader. We have our desktop loader as well. We have more advanced tools, as mentioned here. You could also view images with JOSM ArcGIS, which is a good integration that we currently have. And of course, you could edit the map utilizing JOSM and our Rapid and developer tools as well. And you could also help beta test, as mentioned here. With all of that, I do encourage everyone to join our community and our different social groups and start contributing or join our missions, as I mentioned in my first presentation. And that'll be all. Thank you, everyone.
Great, thanks, Albert. We do have one question in the chat. So I was curious who owns and runs a Mapillary.
So Mapillary now has been, Mapillary was acquired by Meta, I think in 2 years ago. So now we are under the Meta products.
Great, thank you. We'll have other questions roll in. And so hopefully at the end, we can bring you back on and answer more questions that come in.
Yeah.
But thank you for both of your presentations. Next up, we have Ruben. Ruben, you're on screen, pulling up your presentation.
Yeah.
Take it away.
Nice. Can you hear me? Yeah, my name is Ruben. I am from Peru. I am part of the Development Seed data team. I work for Development Seed, which is a company that works to solve world hardest problem with open data and geotechnology. So today I'm going to talk about OSM Seed, which is a tool for packaging OpenStreetMap software in Docker containers. As you may already know, there are plenty of softwares that is part of OpenStreetMap. One of them you see it's the OpenStreetMap website. We have OpenStreetMap website offers the API. We have Overpass for extracting information, Nominatim for geocoder. We have the other tools like ID and JSON for editions, tag info for getting stats. We have Osmosis for processing data. There are a lot of data. There are a lot of softwares, which is in many repositories. But what does exactly do OSM Seed? It's packaging all of these softwares into containers that make it easy to start up each of these softwares. For example, we have here kind of a diagram that we have the API database, we have the OSM OpenStreetMap website API, and we use ID editor for making the editions, and also we can have the populate API, but which we use Osmosis, something like that. Next one. But who uses OSM Seed? I think one of the main organization that is using OSM Seed is Open Historical Map, and which is used for getting information from historical places and how they come to be. You see here, this is an animation of the Open Historical Map from different years. Who else use? We have Open Geofiction, uses to create places that are made up and checking the complexity of the you can see here the complexity of the highway. Who else uses? We have OpenSeaMap, which is for collecting nautical information based on OSM data. I want to show like how can we start up OpenStreetMap database and website in a couple of minutes using Docker. And I have already some GIFs to do that. What you need exactly to do here, it's just to clone the OSMSeed OSMSeed repository. You make some, you run some command lines like cd into the folder and run docker compose. And you see here in the GIF, it's starting the database, and then it's going to start the website. It takes a couple of minutes. It can be 10 minutes. It depends on your internet. Now, once you run, you load your local host, and you have the website ready to use. And then you can sign up in the local website. For example, here I already signed up with some information that I complete here. And then what is interesting is once you sign up, you logging in, and then you can do it kind of some editions in the website locally. You have your database and your OpenStreetMap website there, and you make some addition. You can integrate, well, in this GIF, it's showing ID, but also you can integrate that addition, or you can use JSON for making additions. Yeah, we can start up OpenStreetMap website using Kubernetes as well, but it takes a little more time. But we have here some templates, which is in Helm, that you can use to run the software, the OSMC software in Kubernetes. Yeah, that's it. I hope that gives you an idea how OSMC works, and yeah.
Thanks, Ruben. We do have a question for you, but before we dive into that, I'm going to pull the other speakers back on in just a minute, so we'll have time to answer those other questions. But while you're here, Ruben, we do have a question. I'll pop it on the screen. So can OSM seed be customized to use a subset of OSM data?
Yeah, it can be customized. You can import some extra data from OpenStreetMap into OSMSeed using the Osmosis, which is one of the containers in the OSMSeed folders there. Yeah.
Great, thank you. And it looks like a link to OSMSeed has been shared in the chat. Okay, well, thank you. I'll keep you on, Ruben, just in case we have other questions. I'm also going to pull Lisa on stage, and if the other speakers can come on. There we go. There's Albert, and I'll pull the others on as well. So let's see here. So Albert, there was a question for you from Yuri. Can I download all of Mapillary raw imagery for my own processing? Any special licenses for that?
I think I need to follow through with that, Yuri. If you could give me your contact details, I could possibly answer that question through email. So I'll be happy to kind of follow through with that.
Great, thank you. And then there was a question for Lisa. Is any of the tooling that you were describing available for OSM use?
You know, I'd have to follow up with you on that. I'm not aware of any backwards moving capabilities in that area, but I could definitely point you in the right direction and get some answers for you. Appreciate the question.
Thanks, Lisa. And then I think, apologies, losing them in the chat here. I think this other question from Yuri was for Mike and Jennings. If that doesn't look like that should be for you, then let me know, we can sort it. But what license do you have for the schema of the data?
Yeah, we've been sort of chatting in the thread. So my recommendation was just to reach out to the email I pointed in there. You know, we can kind of go back and forth. But essentially, I'm not legal enough to answer that question.
Great, thank you. And then we did have a question from Diane, and I believe this was for Chad. What is the project proposal process for a mapping campaign for micro?
To propose something to us, I think, yeah, we would just have a conversation and try and spec it out from there. Try and understand which features you want mapped, what tool you're going to use to do that, how much you're willing or can afford to pay mappers to make those edits. And then we can kind of design one each custom at this point.
Great, thank you.
Thanks.
Okay, I don't see any other questions. If I missed any questions in the chat, please feel free to resubmit it to the chat. Other than that, I think we will end the broadcast here, but I encourage all of our speakers to go back into Hopin and answer any questions in the chat that come up. But thank you all so much for your time. This was definitely a great highlight of all the different tools in the ecosystem. So thank you very much.
Thank you.
Thanks, everyone.
Thank you all.
See ya. Bye-bye.
Thank you.
Bye-bye.
can see that it is in fact broadcasting. All right. And hopefully somebody is now checking that things we say are translated to Spanish and are clickable from the front end. Could you say something intelligent?
No, I don't think I can say anything intelligent.
Well, it may be intelligent when in Spanish. Give them a chance. We just have to keep words flowing to see if they come through.
Yeah, I think there's a delay.
We just have to keep words flowing to see if they come through.
Yeah, I think there's a delay.
I think the plugin is not quite working. I can't actually select Spanish. Let's keep talking.
Okay. I thought it was live. Sorry, I lost my.
Somehow it's not activated in the interface. That could just be a matter of timing. I'll mute myself to check if I'm getting any advice on the software question.
Okay.
I'm told it is working better now. Let me check whether the Spanish interpretation is working correctly right now. Hello, attendees. We're not quite ready to go. We'll be back shortly. Ian, should we ask Sherry to come separately?
You mean send her another invitation?
Yes.
Sure, but we can get started.
Okay, then. Ian, well, our Spanish interpretation is working. Please introduce yourself and go ahead. And for the interpreter's benefit, don't speak too quickly.
Hi, everyone, and welcome to Wikimedians of the Caribbean's latest project, where we're going to talk about launching our 100 Caribbean leaders on Wikidata. So this is a new project of ours that we're getting started at WikiConference North America. So just to introduce ourselves, Wikimedians of the Caribbean is a Wikimedia user group, and our goal is to bring together the cultures, the languages, and the communities of the Caribbean, the Greater Caribbean, and the Caribbean diaspora. Because like a lot of places in the world, a lot of the Caribbean people actually live outside their countries of origin. I'm from Trinidad and Tobago, but I live in the US, so I'm diasporan myself. And language-wise, the Caribbean has four major languages: English, Spanish, French, well, Haitian Creole, and Papiamento. So I can't count very well. Hopefully, Sherry will be joining us soon. Sherry Antoine is the leader of our group, the lead organizer. She is also the executive director of AfroCrowd. She's originally from Dominica in the Caribbean, which is not the Dominican Republic, and it's a different island. And she lives in New York. I'm Ian Ramjohn. I'm part of the leadership team of WikiCarry. I've been a Wikimedian for quite a while. My account turned 18 this summer. And in my other life, where I'll be speaking later today, I'm also a Wikipedia expert at Wiki Education. Now, the focus of Wikimedians of the Caribbean is celebrating the Caribbean, celebrating the diaspora, and our goal is to get more of who we are onto Wikipedia and Wikimedia, broadly speaking. And to do that, we have a monthly working group. We have some outreach from the user group and a number of activities throughout the year. We were involved in a digital human rights initiative this year, and two of our major features of the year, Caribbean Festival, which we started because New York City's Caribbean Day couldn't happen due to that pandemic, and our Earth Week, where we're hoping to do a lot this coming April. If you want to know more, you can go to wikicarry.org. You can follow us on Twitter, assuming Twitter is still there, at WikiCaribbean, or the hashtag WikiCarry. So what I want to talk about today is the Caribbean on Wikidata. Caribbean is a historically marginalized region. We're underrepresented in the Wikimedia world. We're underrepresented on Wikidata, and it's a historically disempowered area. We're the products of slavery, indentureship, exploitation. So we're used to it, but we're trying to do something about that in the Wikimedia world. It's also important because the Caribbean and the diaspora are very often stereotyped. A lot of the time, we're sort of seen as, not non-threatening, good-natured, friendly, like a party, like the beach. And while there is truth in a lot of stereotypes, there's a lot more and a lot more that's interesting, and also a lot more that's important to represent in order for us as a people and a region, or peoples in a region, to um, to appreciate ourselves. So, you'll only do what you can envision yourself. You'll only be what you can envision yourself being. One of the challenges that people at the Caribbean have in a Wikipedian and Wikidatan context is the fact that we like to pigeonhole. We, being Wikimedians, we feel the need to pigeonhole people. So every Wikipedia biography begins with person is a nationality, occupation. And nationality is a complex concept where, if you're in the English-speaking Caribbean, until 1962, we were all part of the British West Indies, and there was a lot of movement between islands. There's a lot of movement from the islands to the metropole, to North America, Europe, Britain, and it can be difficult to figure out how to pigeonhole people. One debate that I got into a few years ago was how to characterize the Nicki Minaj, because Wikipedia's sort of norms, at least in English, is to give somebody the nationality of where they became famous. But if you read what she's written, she talks about having been an undocumented immigrant in the U.S., and also talks in one election cycle about not being able to vote. So, that suggests that she's not a U.S. citizen at all, but it doesn't prove anything. So it's often hard to fit our norms into reality of the world, and it's important to get it right, because we have a huge we the Wikimedia movement have a huge influence in how the world sees things. So, and then the other thing is, within the Caribbean, people may be born on one island, especially like academics. They might be born in one island, get their education at another where there is a university, move to a different university, perhaps work at home despite being employed by that university. So there's a lot of movement back and forth. There's a lot of historical identification, which may not reflect the island you were born in. You might have been born on one island, but you identify more with where your parents came from and you grew up in a third place. It's also important to escape the beach narrative. So talk about the Caribbean, it's the beach. There's an awful lot more than the beach. There's rich life, culture, society. There are real social and economic challenges. There are challenges, especially in the bigger islands, of violence, crime, drug running, corruption. All these things that that aren't really convenient to the tourist narrative. There is also the impact of climate change. Many of the Caribbean nations are tiny, have all their key infrastructure close to sea level, and dealing with rising sea levels, dealing with increased strength and frequency of hurricanes, and simply the increased rain events associated with climate change is a huge deal. And these are things that the need to be represented on Wikipedia and Wikidata in order to more appropriately, treat these regions like the rest of the world. Because if the goal is knowledge equity, if the goal is the sum total of human knowledge, that includes areas outside of North America. That includes the rest of the world. And just natural disasters are interesting because we talk about hurricanes, but we don't talk about the floods that are coming more and more often. Now, a little case study here of what you can do with richer data on Wikidata. Obviously, Barack Obama is not a West Indian, not a person from the Caribbean, but he's one of the few people that I could find easily where his residence throughout his life is well represented. And you can see Hawaii, California, Chicago, New York, DC, and Jakarta, or was it Jakarta? Anyway, Indonesia. This is something very powerful that Wikidata is capable of doing, but it's a way to represent the peripatetic, the wandering nature of Caribbean people. I would have liked this to be CLR James, but the data isn't on Wikidata yet, and it takes, obviously the answer is so fix it, I should have, but it takes some effort to find the time to put all this together. So enriching not just the number of people on Wikidata, but the completeness of their records is an important part of our goal of more accurately representing and understanding Caribbean people. So to that end, we have launched an initiative, or we are launching an initiative. We're launching a wiki project to add 10,000 to add or improve Wikidata items for 10,000 people in the Caribbean. There's a lot to be added. There's a lot to be expanded. As I was looking through people to include in these lists, sometimes I found people with a Wikidata entry, and that had so little information that it took considerable work to know that this was the right person, that this represented the Jackie Hinkson I was talking about and not another person by that name. And what I want to do today is to ask people in the community to participate in the first phase of this project, which is to add 100 Caribbean leaders, 100 Caribbean, not necessarily leaders in the sense of people who have done something noteworthy, not so much political leaders. And I'd like to ask everybody here to join us in doing this. It's not the easiest thing to figure out who isn't there, because it takes some knowledge, some depth of knowledge to understand where to look. It's easy to look at a list and say, okay, this looks pretty complete, but it's really hard to identify the gaps, to identify what's missing, takes more depth of knowledge. I was surprised when I went through the list of Trinidad and Tobago people and dug through it. I was able to easily find my goal of 10, and then I kept going a bit. All of these people, I think, could easily have Wikipedia articles. They're easily notable enough for that, but they don't even exist on Wikidata. I then looked at people who had been awarded the Order of the Caribbean Community, which is the English-speaking Caribbean's highest award, and pretty quickly found two who weren't there. I looked at awardees of Jamaica's highest award, and I found three more that aren't on the list. So, you know, there's a lot that could be added. I think 100 is a very modest goal, but I would like to add people. I would like to, you know, we rather would like people to join us in adding 100 new Caribbean notables to Wikidata. If you're interested, please sign up for our campaign. This is a link to the dashboard, and the dashboard has a link back to the Wikidata Wiki project page. You can sign up there and make some additions to Wikidata if you would. And I realize that I'm sort of out of time at halftime. My challenge here is that I was only planning to do the second half. I'm not sure if Sherry had some problems getting in. But I really, this is all I really have right now. I sort of did a condensed version of her half. So I'm, open for questions.
That's good. Okay, we'll watch for questions in the chat. If we see Sherry, we'll welcome her on stage. I'm quite interested by the issue you mentioned of showing nationality. And it does seem to put a peculiar twist on things in biographies around the world to emphasize people's nationality. If you had further comments or advice on that, I'd be interested to hear it.
Well, it is sort of, it's our convention to start off by saying this person is and put them in a sort of nationality pigeonhole. Is there a reason that we start that way? That's a question. It probably reflects, well, it's more widely done. We aren't the only people who do it, but it also, I think, reflects the fact that Wikipedians by their nature like to put things in boxes, and they like clear cut. We like clear cut definitions. I'm not criticizing the other. I'm just as prone to that. But that reminds me to go back. Can I go back a bit? The idea of where you move through your life. If you're a genealogist, if you use something like Ancestry.com, you create a page for a person, and it has, say, census records of where they lived in their life. And that really helps you to understand their life and their path. It's not so common on Wikidata, but it is, I think it's an important part of identity. If I were notable enough to have a Wikipedia article, where would I fit in? If I am notable enough, if I were to be notable enough, it would be for things that I did living in the US. But that's, not where I primarily identify. So, I consider myself from Trinidad and Tobago, even though I haven't lived there in a while. But my own life has taken me, I spent part of my childhood in Canada. I've been back and forth to Trinidad. And yeah, what sort of what am I in terms of my own concept of nationality and Wikipedian concept of nationality. That makes sense.
Apart from editing the content of Wikipedia, do you have a vision for how Caribbean participants or organizations should integrate into the Wikimedia movement so as to show their point of view and their knowledge better overall in a way that other organizations should help with?
I have some quite strong opinions, which sort of begin with me carving out more time and being less busy. So one of the benefits that you have in the Caribbean is that the lines of communication are short. There are two current government ministers in Trinidad and Tobago. One I knew from, well, he went to our rival high school, and one I know from undergrad. It's easy to actually get to know people. I know several people, I think the head of public health and the person in charge of PR for one of the major regional health bodies in Trinidad. If we have a project, and that's sort of the challenge of having a project and having the time to organize properly, it wouldn't be that difficult to say, to ask, can we get, some buy-in from a member of parliament? I mean, Trinidad's health minister famously went on all the news networks to answer Nicki Minaj's cousin's COVID problems. It's not, it's a lot easier than, say, getting the US equivalent. Who would that be? Health and Human Development? No.
Health and Human Services is the name of the largest department.
Yeah. Who is that right now? Embarrassed myself by not knowing. Anyway,
Public Health is run by CDC. That's the best known one, yeah. Centers for Disease Control. But go ahead.
Yeah. But it's definitely something where too much we sort of we need to do more, and that's on us as WikiCarry to provide things in the Caribbean to get people involved. Lots of people said, yes, they're interested. What can we do? Because they're not the sort of native Wikipedian type who jumps into editing as soon as you realize you can click the edit button. But that doesn't mean that there aren't lots of ways that we can involve them in improving the encyclopedia. So what kind of help, so to get to your question, what kind of help can people provide? I think the really nice thing that Andrew Lee has done is he has organized a couple workshops when he was in Puerto Rico, and working with us to make it more of a WikiCarry thing, and sort of when you're there, when we have somebody in the movement who is in a place or is going to be in a place, how do we can we sort of connect them with people that we know? So yeah, I don't really see any questions. Unfortunately, I spoke too quickly.
Yeah, it may be that people are having trouble coming into the virtual room. Thank you for presenting to us, and I think we can just here's a comment.
Yeah.
Proceed.
So this is one of the things where you know, we're a little too. We need more people involved in our organizing side, or more time with us. Um, it's sort of the problem of being everybody has jobs and everybody's really busy with 50 commitments at once. But yeah, there is a wealth of stuff, monuments, landscapes, things like that that need to be documented in the Caribbean. I regularly nudge my sister to take some pictures, but it never actually happens. And you know, there is there are a few people taking pictures, but it's sort of we can say, okay, let's have a Wiki Loves Monuments chapter or Wiki Loves Earth chapter or something like that, focusing on the Caribbean. The problem is the people who are taking pictures there aren't necessarily in Wikipedia. The photographers there need to be convinced as to why should I release my hard work as under a free license. So yeah, I mean the Dutch Wikipedia does have something, and we need to. We've we've worked with them, we've partnered with them, but you know it's sort of we need to do we need to do more to involve people, but at the same time, to do that we need to have more people involved, and it's a little bit of the time crunch um, aspect, but it's definitely something that I believe that we can we can do more, and we can involve the movement more. And I know that everybody in the movement is very willing to help when asked. I've never had somebody say, no, I'm too busy, or no, I don't want to help.
There is a prospect of working with OpenStreetMaps if they have active participants in the Caribbean, because this topic of monuments is really overlapping their general interest. We now have an official relation to them. Have you explored that before?
I'll be honest, I've learned so much about OpenStreetMaps in the last day and a half that that I mean, it's got my mind racing in terms of ideas, and in terms of you know, what are the ways that we can link these things, because places, people, everything is. I mean, I've been to OpenStreetMaps for my hometown. I was just looking at it recently, trying to remember where something is, and most of the buildings are not labeled. Most of you know, the maps are much more detailed and fine grained than, say, Google Earth, but they do lack a lot of labels and additions. Which, yeah, it's a there's and well, even more so the open historical maps, which I'd never heard of before yesterday. Um, there, you know, there's no shortage of history in the Caribbean. It was the center of the world's wars for a couple centuries.
I think if we created an effort to venture around the Caribbean to photograph and map and identify and record its monuments and history, that would be the most fun some people could even imagine.
Yeah,
that's a possibility. We can make a project.
Well, yeah, I mean, let's talk.
Okay. We should take a few minutes off, I think, to set up for our next presentation. If you have any last comment, please go ahead. And if not, I think I will stop the broadcast for a few minutes, because we're going to need to set up.
Jane's comment, we're always looking for more female politicians. I was surprised at how well women in the Caribbean are actually represented. Looking for gaps, you know, the women in red have done a remarkable job with women in the Caribbean. There are more, I think it's easier to find women artists than male artists right now. And this is a wonderful problem to have. But yeah, but female politicians, I think, are underrepresented. And the Caribbean is a place where there are a lot of women in positions of power. Female heads of state are nothing new. Female heads of government, female government ministers. I think that, compared to the rest of the world, the Caribbean does well. And yes, there's probably a really good synergy there with adding more women. And please be in touch. If you have ideas, my username is there. The link is there, and thank you.
Okay, thank you, Ian. We will take 10 minutes off and return at a quarter to the hour. Thank you, Ian. had some technical challenges. Sherry is here now to speak briefly to the Caribbean discussion we just had, and then our next speakers will come on after that. Go ahead, Sherry.
Hi, everyone. So good to be here. I want to just briefly mention the WikiCarry project for on 100 Wiki Caribbean leaders, and our presentation earlier with Ian. We just want to make sure everyone is able to connect to the campaign, which is if you go to wikicarry.org, you should be able to find that. Also, you can hashtag us at Caribbean Wiki Leaders. And on Twitter, you can find us at WikiCarry. So it's at WikiCarry. And thank you so much for coming to the session. Looking forward to the next session and excited about those who are coming on next. So once again, if you want to connect with the 100 Wiki Caribbean leaders, please join us on either of those mediums. Thank you very much.
Thanks, Sherry. Great. And anybody who wishes to comment to Sherry, please do so in the chat box, and we'll keep an eye on that.
And I will be in the networking link as well.
Excellent. Okay. Now we move on to our speakers on automatic citations. I'm introducing first Diego, and he will introduce the group. Please go ahead.
Okay. Thank you very much, Peter, and thank you everyone for being here today. So today we will be here with Evelyn Heidel and Nidia Hernandez. We'll be talking about automatic citations in Wikipedia, how they work, and how to fix them collaboratively with a new tool that is called Web2Sit. So I will start with a brief introduction. As many of you would know, references are one of Wikipedia's main pillars. But because Wikipedia is an encyclopedia, so you know that we don't write there things just for the first time, but we usually cite external sources that support what we are saying in Wikipedia. But inserting citations can sometimes be difficult because first we have to know the format, how we should insert citations. But sometimes we can have help from citation templates for that. But even so, one has to go and get the citation metadata, like what is the title of the source we want to cite, the author names, the date, and so on. So to make this easier, if you're using the visual editor of Wikipedia, you know there is a tool which is an automatic citation generator tool. So for example, you can enter a URL that you would like to cite or another unique identifier. You would click on generate, and then a citation would come up automatically. Usually this citation is okay, like all the metadata is fine, but sometimes it might happen then that when you click on generate, you get either wrong or incomplete metadata. So in this example, we see that, for example, the author is fine, the date is fine, and the title is fine as well. But the automatic citation generator thought it was a scientific journal when it actually is a newspaper article, and it didn't have the name of the publishing source, like on what newspaper this was published on. Why this happens? How do automatic citations work in Wikipedia? So when you click on generate, actually what happens is that you're actually using a service that's called Citoid, which is hosted on Wikimedia servers. So Citoid gets the data from the web page and tries to get the metadata out of it. And then Citoid returns the automatic citation. But why does this fail sometimes? Well, actually, to do this, Citoid relies on external software, which is a free software called Zotero, which is also a bibliographic reference management software. And there is a part of Zotero software that's called translators. So when you have a web page and the web page is well structured, like the webmaster put all of the citation metadata embedded on the web page using standards, then we can use just some generic translators to get the citation metadata out of it. And if web pages do this, then we can use the same generic translator for all web pages. Like if web pages have citation metadata embedded correctly, then we won't have trouble getting citation metadata out of them. But this is like the ideal world. And in real world, many websites do not have structured metadata. So to get citation metadata out of them, we need to write specific translators, specific pieces of software that get the metadata out of them. And imagine we have to write separate specific translators for every web page out there. That's a lot of effort. And sometimes it happens that web pages change, even slightly sometimes, and then the translator doesn't work anymore, and the citation metadata now has a bug. It's no longer correct. So how can we fix this? Well, not long ago, the only ways to fix this were three ways mainly. We could either manually fix the citation metadata, like remember when you click generate on the automatic citation generator, then you get an edit button and you can edit the metadata manually, but that takes a lot of time. And also if you do it, you're just benefiting yourself. It's not that you're benefiting the other people that would insert a citation from the same source later on. And sometimes it can be very difficult. Like for example, if the generator got the item type wrong, so like in this example, it thinks it's a news journal article when it was a newspaper article, then that's much more complicated because you have to change the whole template. You can also change the web page, like convince the webmasters to embed metadata appropriately. But that's like the most robust solution, but that takes time because you have to convince the webmaster, and it may not work because maybe they just don't want to do it, or they don't know how to do it. And the other way that you can fix this is you can change the translator. But to do that, you have to know how to program. And not only that, also because this relies on an external piece of software, even if you wrote that program or you fixed it, then you have to get that piece of software into the Zotero code base, and then you have to wait until Cytoid in Wikimedia incorporates that as well. So with this context, we started the Web2Sit project. Web2Sit is a project that has been financed by the Wikimedia Foundation with a project grant. And it started with an idea that long ago user Strinu suggested on the discussion of a separate project that's called Share Citations, which by the way, if you don't know it, it's a really cool project proposal. So this person proposed, why don't we have a way to visually build translators so that we can do this maybe more collaboratively, maybe more in a visual way. And that's how Web2Sit started. And Web2Sit has three main branches. We have a research branch in where we are trying to where we try to see how often Cytoid was getting incorrect results for citations. Then we have our development branch where we developed a set of tools to collaboratively fix this. And we also had a very important community branch where we tried to build a sustainable community around the project. Given that this is a community effort, we need a community to work on it. So that's the purpose of this third branch. So to get started with this project, I'm gonna now leave the stage to Nidia. Nidia Hernandez is part of the research subgroup of the Web2Sit project. And she's going to be talking about, well, how wide is really this Cytoid gap? How often does Cytoid fail on citation metadata? So Nidia, up to you.
Thank you, Diego, for the introduction. Bueno, yo voy a hacer el resto de la presentación en español, así que, bueno, gracias a los intérpretes por su trabajo. Entonces, como bien dijo Diego en el inicio, yo voy a hablarles acerca de la evaluación del desempeño de Cytoid, de esta herramienta de generación automática de citas. Próxima diapositiva. Bueno, Diego ya un poco les presentó los resultados, ¿no?, de estas citas automáticas, que muchas veces, como vemos en la parte de arriba de la diapositiva, no se corresponden con la expectativa que tenemos de una cita correcta, que es lo que tenemos en la parte de abajo de la diapositiva. Próxima diapositiva. Si lo analizamos un poquito más en detalle, vemos que en la cita automática tan solo tenemos información de título y una información mal detectada, porque dentro del título también tenemos en la última parte información acerca de la fuente de publicación, Jeune Afrique, que, bueno, como vemos en la parte de abajo, en la cita correcta, bueno, es la fuente de publicación, que ese es uno de los datos, uno de los metadatos que queremos recuperar. También nos interesa recuperar información acerca del autor, apellido del autor, nombre del autor, fecha de publicación, bueno, y título bien identificado. Esta comparación que estamos haciendo ahora entre la cita automática y la cita correcta fue realizada, de hecho, en un estudio llevado a cabo por Andrew Lee y Robert Fernández en 2017. Fue un estudio que evaluó manualmente 91 URLs concentrado en fuentes de noticias en inglés. En nuestro caso, en nuestro trabajo, lo que quisimos hacer fue realizar un trabajo más masivo, ¿sí? De evaluación masiva de citas. La casualidad dio que también dio 91 el resultado, pero 91.000 URLs. En nuestro caso, evaluamos 91.000 URLs de todo tipo de fuentes, no solo de noticias, y en un corpus multilingüe en inglés, español, francés y portugués. Próxima diapositiva. Entonces, bueno, nuestro enfoque es un enfoque automático. En lugar de comparar la visualización de la cita, lo que hacemos es automáticamente comparar la respuesta subyacente, ¿no?, del JSON que devuelve Citoid, con la información de cita estructurada dentro de las plantillas de citas, ¿sí?, que es lo que tenemos a la derecha de la diapositiva. Comparamos, ¿sí?, la respuesta de JSON, que es la parte de la izquierda, con las plantillas de citas, que es lo que tenemos en la diapositiva de la derecha. Bueno, obviamente el mayor desafío para el subproyecto de investigación fue encontrar una gran cantidad, un corpus importante de citas correctas. Bueno, la respuesta a este desafío fue trabajar, la siguiente diapositiva, fue trabajar con... ahí, gracias. Fue trabajar con los artículos destacados de Wikipedia, ¿sí? Trabajamos con artículos destacados de Wikipedias en distintos idiomas, y de ahí pudimos extraer las plantillas de citas, los citation templates. Próxima diapositiva, por favor. Ahí está. Bien, entonces, una vez que identificamos, ¿no?, los citation templates, también tenemos, bueno, nos enfrentamos con otras dificultades que fue, bueno, de hecho, la gran diversidad de plantillas de citas que existen dentro de Wikipedia y entre Wikipedias de distintos idiomas, y dentro de cada plantilla de cita, identificar los parámetros, ¿sí?, que corresponden a los metadatos que queríamos identificar. Nosotros, bueno, yo ya les presenté más o menos en una de las primeras diapositivas cuáles son los metadatos que nos concentramos para evaluar. Fueron los que están en el recuadro de abajo a la derecha: tipo de fuente, título, nombre de autor, apellido de autor, fuente de publicación y fecha de publicación, ¿sí? Nosotros nos concentramos en evaluar el desempeño de las citas automáticas para estos datos, que, bueno, los vemos identificados en la respuesta automática de JSON por un lado, y en la respuesta en una cita correcta, curada manualmente por un wikipedista en la plantilla de la derecha. Y vemos que, bueno, obviamente reconciliar, ¿no?, poder identificar, extraer esta información, bueno, conlleva cierto trabajo de revisión cualitativa, manual, de estudio de la variedad de los citation templates. Bueno, entonces ahora en la siguiente diapositiva les voy a comentar muy brevemente cuáles fueron las diferentes etapas por las que pasó el proceso de evaluación. Entonces les decía, comenzamos con la identificación de las plantillas de citas, de las citas manuales dentro de este corpus de artículos destacados. Una vez que identificamos las citas ingresadas con plantillas, lo que hicimos fue extraer los metadatos para cada una de esas citas, los metadatos para título, autor, fecha y fuente de publicación, y también la URL correspondiente a esa cita. Estas URLs, a su vez, fueron las que nos permitieron solicitar a Cytoid citas automáticas, ¿sí? Las citas automáticas que luego normalizamos para la comparación, ¿sí? Realizamos toda una normalización de los datos, normalización de los metadatos extraídos de las citas manuales y también normalización de la respuesta de Cytoid. Básicamente, ¿no? El paso más importante fue realizar todo este mapeo que les comentaba recién de los metadatos de nuestro interés. Y por último, sí, ahí realizamos la comparación de los resultados. Bueno, entonces en la próxima diapositiva les voy a comentar acerca de los resultados, ¿sí? Este es, bueno, el resultado principal acerca del desempeño de Cytoid. Acá lo que podemos ver es el desempeño por dominio, ¿sí? Nosotros evaluamos 91.000 citas y esto dio como un total, agrupadas por dominio, una evaluación para aproximadamente 15.000 dominios. Y lo que podemos ver es que para los 6 campos evaluados, Cytoid devuelve un promedio de entre 3 y 4 respuestas correctas, ¿sí? Ese fue el resultado al que llegamos. Obviamente, bueno, tenemos muchos dominios con bajo número de ocurrencias y pocos dominios con un gran número de ocurrencias, ¿sí? La distribución no es pareja. Y bueno, luego en la segunda parte, en la que voy a hablarle acerca de las pruebas de traducción, vamos a ver esto un poquito más en detalle, pero si les interesa explorar los resultados de su proyecto de investigación, pueden consultar nuestro informe final, que se encuentra ahí en el link que tienen ahí abajo, y si les interesa saber más acerca de los scripts y los datos usados, también pueden consultar nuestro repositorio de GitHub. Bien, Diego, si quieres continuar.
Bueno, muchas gracias, Nidia. Thank you very much. So yes, by the way, 2 things. First, I was like, for a minute, I was disconnected. I had an internet problem myself. That's why it took me some time to continue to the next slide. I hope it doesn't happen again. And also, we will find a way to share these slides later on. I'm afraid we couldn't share them before, but probably we will find a way through the Web2Sit page on Meta. So maybe on the news part, we will share a link to the slides if you need to get these links later on. Yeah, thank you, Evelyn, for sharing the link. I think you have to share it to the comments so that it goes to Hopin instead. So the next thing we're going to introduce now is the development part, like the tools we developed to fix this situation collaboratively. So the idea behind Web2Sit is not to be a replacement of Cytoid, but rather to complement Cytoid. So Cytoid is working in between the visual editor and the Cytoid workflow. Like when you click on Generate now, if you have the Web2Sit user script installed that integrates Cytoid into Wikipedia, then the request is going to pass through Web2Sit first. It's going to use the responses from Cytoid if those are okay, and those that are not okay are going to be replaced by those defined collaboratively by the community using Web2Sit. And you will see that you will get now 2 results instead of 1. The one at the top is the one from Cytoid, the usual automatic citation generator, and the one below is the one from Web2Sit. You would notice here that the 2 are the same, but that's because Web2Sit has not been configured for this domain yet. But we can change configuration for this domain by clicking here where it says Web2Sit. By the way, we don't have time in this presentation to give a step-by-step way to use Web2Sit. But if you go to the web-to-sit page that I'm gonna show the link later on, you will find there documentation, instructions. We also have some workshops that we have recorded. This is just like a general overview. So how does web-to-sit work? What is the idea behind it? So if you have this web page, for example, then the first thing that the web-to-sit community has to do with a web page that is not working okay with the citation generator is define, a test for this web page. And a test is a document that is created collaboratively, is a piece of configuration where the web-to-sit community indicates what is the expected output for every citation field for that given web page. Like, for example, okay, for this web page, we want the answer to be that this is a newspaper article. We want the title to be this title because this is the correct title. We want this to show up on the published in citation field because this is the publisher or actually the newspaper where it was published in. So, and this is defined collaboratively. One can start defining something, but then other people in the web2sit community can come and improve that configuration. Next, web2sit by default would return for a given web page more or less exactly what Cited was returning, which in this case we saw in the example was incomplete. Remember that it was given a wrong item type and it wasn't given published in a citation field. But as we said before, good thing about web2sit is that we can change the configuration. So to change the configuration so that the output changes, the web2sit community defines a citation translation template. And these translation templates simply say, like for all these citation fields, the community indicates a procedure to get this metadata out from the web page. And this procedure, again, I'm not going to get into details here, but it has like a series of selection steps and a series of transformation steps. Like saying, okay, select this and this metadata from the source. You can also select the cited response because, as we said, sometimes and usually cited returns correct metadata. So we can reuse the metadata from citoid. And then we can add to it some transformation steps as well, because sometimes the selected metadata doesn't have the correct format. So we can continue like transforming the metadata until we have what we wanted, until the output matches the test that we have defined. Yeah, so both tests and templates are collaboratively defined by the web2sit community so that the output is what we expected for a given web page. And I will probably not have enough time to show this, like to demonstrate this, but just very briefly, let me see if I have. So this is like my Wikipedia sandbox, and I wanted to enter a citation for this URL. So I click here on site. Because I have the web2sit user script installed, I have this checkbox here. I click on generate, and as I showed before, I'm going to get two results here, one from Citoid, one from web2sit. If I want to change it, I click here where it says web2sit. And here we will see, first of all, that somebody has already configured a test for this web page. This is like the expected output for this page. But we see that for two fields, the metadata is incorrect. That's shown here in the score column. We see that there is a 0% match for those fields. And if we click here, we can edit the translation template so that the output changes. I'm not going to do this, but I was planning that maybe I wouldn't have time. So I've already done it here. Again, you can check our workshop recordings, but mainly for each citation field, I have defined the procedures to extract the metadata. So I would just save this configuration. This configuration file is collaboratively again. So I start this configuration, but then other people can join so that they can improve it. And once the configuration is saved, if I refresh this page, you will see that now the citation metadata matches for all fields. And if I try to insert the citation again here on Wikipedia, if I have the web2sit user script installed, the one at the top is again the one from Citoid, and the one at the bottom is the one from web2sit. You can see now that the item type has been corrected, and also the published in source has changed as well. And okay, let me go back to the presentation. Just one second, I have to find it here. Okay, I see if I have any comments. Okay, so very briefly, so that we have time for the other topics, just just to mention this, is not that we will have to create one template for every web page. The magic behind Web2Sit is that we can use the same template to translate other similar web pages from the same domain. Like we have this other web page, we can apply the same template as above to get a citation output. And in case we find a web page that has an incorrect output using the template that we have defined, then we can just simply create a new test for that different web page. We can create as many tests as we want within a domain, and we can create another template based on this other web page. And Web2Sit is going to use some rules that you can read about in the documentation to decide which template they have to use to translate a given web page, so that you can define several templates within one domain. And well, as I said before, you can read more about Web2Sit on the Web2Sit page on Meta. And here you can find information about how to install the user script, get started, how you can contribute to Web2Sit configuration. If you need help, you find links to deeper documentation and to support channels. And you can also watch, as I said before, the recordings of some of our workshops, which Evelyn is going to talk about in just a minute. And just to end with this introduction about the tool, as we said before, it can happen sometimes that the web pages change. And if web pages change, the procedures that we define on the templates may fail. And also, because templates are collaboratively defined, maybe accidentally, somebody changed the configuration and included a bug. And that would mean that the citation output is going to be wrong now. So as a community, how can we find out if this happens? How can we find out if a web page has stopped working with Web2Sit? Well, to do this, one recent addition to the Web2Sit ecosystem of tools is the Web2Sit monitor, which has been developed by one of Web2Sit development team members, Denis Tovar. And in this monitor, which you can find in this link up here, lists all the domains for which Web2Sit has some configuration defined. This list has incredibly grown in the last kind of 3 days because two new contributors have joined the Web2Sit community from French Wikipedia, and they added like configuration for like 50 domains already. And if you click on any of these links, you would see like the details of the tests. These tests are the results of comparing the test defined by the community versus the actual result returned by Cytoid. You would get a score for each of these tests. And good thing about these pages is that they only change if the test has changed. This is checked regularly, like every hour, if there has been a change in the configuration for a domain, or if a domain has not been checked for the last 30 days. And if you can add this page to your watch list, and if you're interested in a particular domain, you would get a notification whenever a test result changes. So if you're interested in a particular domain that it should work on Web2Sit, just add the result page to your watch list, and you will get a notification if any test breaks. So because these tests are very useful, as I've just shown, to check the status of Web2Sit, how well it's working, these tests are manually defined by the community, but the research team has experimented a little bit on automatically creating them from their research results. And that's what Nidia is going to talk to us about now. I think you're muted.
Yes. Thank you, Diego. Bueno, entonces, como Diego les dijo recién, en el subproyecto de investigación recabamos esta enorme cantidad de citas correctas que nos dimos cuenta que podían transformarse en un recurso para la comunidad. Entonces, bueno, decidimos tomar esta gran masa de información para generar automáticamente tests de traducción. Podemos pasar a la siguiente diapositiva. Bueno, obviamente el traspaso no es del todo evidente, no es del todo lineal. De la serie de metadatos que recuperamos, no todos pueden traspasarse automáticamente a los campos de los tests, de las pruebas de traducción de Web2Sit. Hay ciertas informaciones, ciertos metadatos que no recuperamos, como puede ser el idioma, o algunos casos en los que hay campos de Web2Sit que están cubiertos por un solo campo de los que recuperamos, como es el caso de publicado en o publicado por, que estaba cubierto por un solo campo de los metadatos que extrajimos, o el caso del tipo de fuente, ¿sí? El source type. En la siguiente diapositiva vamos a ver que lo que recuperamos de una plantilla de cita, ¿sí? Como puede ser site web, citar web, cita publicación, site journal, site thesis, no tiene una correspondencia uno a uno con los tipos de fuente que podemos encontrar en Web2Sit. Entonces, bueno, lamentablemente en ese caso, para ese campo en particular, no pudimos usar esa información, pero en la siguiente diapositiva, bueno, vamos a ver que del gran conjunto de 91.000 citas y en realidad 15.000 dominios que pudimos recabar, obviamente no vamos a generar pruebas de traducción para todos los dominios, porque en muchos casos Cytoid ya funcionaba bien. De hecho, bueno, en este gráfico lo que podemos ver es la representación del desempeño de Cytoid para los dominios. En el eje horizontal vemos la cantidad de respuestas correctas. ¿Sí? Habíamos visto que teníamos 6 metadatos que queríamos recuperar. Entonces, cuanto más a la derecha nos vamos en el gráfico, mayor cantidad de respuestas correctas. Bueno, en el eje vertical podemos ver la popularidad, está representada la popularidad de un dominio en particular, ¿no? Y tenemos, digamos, en la zona baja, ven que el color es más oscuro. ¿Por qué? Porque, como les decía antes, tenemos una gran cantidad de dominios que se usan muy pocas veces, ¿sí? De hecho, la primera franja es de dominios usados tan solo una vez. Y cuanto más arriba vamos en el gráfico, tenemos dominios que se usan, que son citados mayor cantidad de veces, ¿sí? Hasta llegar a la franja de entre 1.000 y 10.000 citas, ¿no? Como es el caso, por ejemplo, de Google Books, que en nuestro corpus lo encontramos citado más de 8.000 veces, por ejemplo. Entonces, bueno, para los tests de traducción decidimos concentrarnos en dominios para los cuales el desempeño de Cytoid, del generador de citas automático, no fuera bueno, porque no tiene sentido ya generar una prueba de traducción para los casos en los que la traducción automática ya funciona bien, la cita automática, perdón, ya funciona bien. Entonces nos concentramos en los dominios que se encuentran a la izquierda de la línea vertical, ¿no? Tenemos una línea vertical trazada que nos divide el gráfico. Bueno, nos concentramos en dominios que tuvieron 3 respuestas correctas o menos, ¿sí? Que nos devolvieron información correcta para 3 campos o menos. Y también decidimos concentrarnos en dominios que tuvieran alta popularidad, ¿no? Porque, bueno, tampoco tenía sentido generar pruebas de traducción para dominios que no fueran muy usados. Por ende, bueno, terminamos seleccionando el subconjunto del cuadrante superior izquierdo, ¿sí? Dominios de alta popularidad y bajo desempeño de Cytoid. En la siguiente diapositiva vemos el resultado de este trabajo de generación automática de pruebas de traducción dio como resultado 40 pruebas de traducción que ya se encuentran disponibles en nuestro repositorio de GitHub y que muy prontamente van a estar siendo subidas a los servidores de Web2Sit. Y como les dije antes, ahí tienen los links por si quieren ver un poquito más de detalle acerca de todo el proceso de generación o analizar los datos con mayor granularidad. Ahí tienen algunas notebooks de visualización de resultados. Bueno, por supuesto, todo este trabajo es un trabajo para la comunidad de Web2Sit, para facilitar el trabajo de la comunidad de Web2Sit. Así que ahora le dejo la palabra a Evelyn, que les va a estar hablando acerca de esto.
Hola a todos y todas. Yo no sé en qué idioma hablo ya, así que voy a hablar en castellano. Muy breve, porque además también veo que tenemos preguntas en el chat y creo que estaría bueno responderlas. Bueno, una parte muy importante fue el tema de la comunidad dentro de este proyecto, porque en efecto cuando Diego presentó el grant, una de las partes importantes era la sustentabilidad, porque como todos ustedes sabrán, muchas veces eh, los proyectos de software es difícil que se mantengan más allá del interés inicial de quien lo desarrolla. Entonces, para eso creamos una estrategia alrededor de la comunidad y en ese marco se creó un consejo asesor, un advisory board, que la idea era también que el advisory board se sintiera parte del proyecto y nos ayudaron a crear documentación, a pensar algunas de las decisiones que tomó Diego y sobre todo conectar al proyecto con diferentes oportunidades. Y esas oportunidades podían ser, bueno, charlas, comentar de posibles workshops, diferentes, digamos, oportunidades que pudieran aparecer. También la idea era inspirar a otros miembros de la comunidad para que hicieran talleres, workshops y conectar y conectarlos con otras tareas que pudieran tomar del lado de desarrollo. Todas las diapositivas y videos de otros workshops están ahí en el link que ya pasamos en el chat. Y ahí pueden ver los diferentes workshops y si tienen ganas también pueden dar un workshop sobre Web2Sit, ¿no? Ahí Phoebe estaba preguntando si hay alguna forma de colaborar con Web2Sit más allá de hacer pruebas. Bueno, una opción es hacer workshops, por ejemplo, en tu comunidad de bibliotecarios o bibliotecarios. Esto es una linda tarea para hacer, para contarles más del proyecto. También existe la posibilidad de participar en la traducción colaborativa. Ahí está el link y ya hay más o menos unas 10 traducciones de la interfaz de Web2Sit y eso nos ayuda además a expandir Web2Sit a otras comunidades que no hablen inglés o español, sino que también hablen otros idiomas y que esto es particularmente importante porque, bueno, sabemos que ahí hay todavía más desafíos para las traducciones de sitios web. Y por último, en la página principal hay información sobre cómo pueden contribuir más allá de crear citas, perdón, de crear pruebas. Y bueno, ahí, Diego, hay varias preguntas en el chat. No sé si querés que te las lea o si querés que...
Ahí las vi, Evelyn. Gracias. I will just like end the presentation and go to those questions. Thank you all. But I don't want to like finish the presentation without thanking the amazing team that I had the chance to work with this project. Well, Evelyn at the communications and community sub-project, the people from the research sub-project, Jimena del Rio, Nidia Hernandez, and Romina de Leon, and Denis Tovar, who joined the project to develop the Web2Sit monitor. Really an amazing team and a great pleasure working with all of them. Thank the Wikimedia Foundation for supporting the initial development of this project, the advisory board who helped us from the beginning of the project to give us feedback or discuss important topics, and the Web2C community, which is a growing community, but which has already done lots of work to improve automatic citations in Wikipedia. So thank you all, and thank you all as well for being here and for the questions. And well, regarding the questions and addressing first Phoebe question, which asked, Evelyn addressed that a little bit regarding the problematic URLs, spreadsheet that we had created at the beginning of the project as a way to report URLs that were not working well with web with Cytoid. Sorry, we're trying to phase out that spreadsheet. But anyway, because reporting that a URL is not working okay would also mean indicating what the correct response would be. We really think that creating a test for those cases is the best solution, because I mean, you could maybe open a thread on the Web2SIT discussion page and report this there. But as you would anyway have to say what you were expecting to get there, maybe it's a good investment to learn how to write this Web2SIT test and report it as a test directly. But you can also use the discussion page. And on the Web2SIT page, there is a section that's called Contribute, and you can find there other ways to contribute to the Web2SIT project in addition to those that Evelyn just shared with us. Like, well, for example, if you're a developer, you can also contribute to the source code, etc. And then going to Tisare, sorry if I mispronounced that question, whether it's possible to generate text templates that we can then edit, and you're referring to this OCLC number that you can find in thesis or scholarly articles. I'm sorry, I'm not 100% sure what the question is about exactly. Sorry about that. But given that you mentioned the OCLC number, I wonder if I don't know if you can further expand this question if we have time. But regarding the fields that Web2SIT currently supports, I would like to mention that it doesn't currently support all fields that Cytoid supports right now. So if the OCLC number is a field that was supported by Cytoid before, but Cytoid, sorry, this is not a field that is currently supported by Web2SIT, although we plan that Web2SIT can support more fields in the future. And if it is not a field that is currently supported by Cytoid, we can anyway plan to support it in the future with Web2SIT. And for that, you can read the Web2SIT page and find ways to suggest new features. You can post them to Fabricator or to the discussion page. And regarding your question about whether this would work with the Internet Archive, I assume it would, because the Internet Archive, when you open a web page, it should that is archived on the Internet Web Machine. You should get the same metadata, embedded metadata, and the same page structure that you had before. So I don't remember if we tested it, but I assume it would work. The only thing is that because I'm thinking in loud voice, because Web2SIT works on a per domain configuration basis, we might have a problem there because all these web pages would be from the same domain. So it might work actually, now that I think of it. And sorry that I'm in a rush, but we had to finish like now. So I give the voice to you, Peter.
Thank you for telling us about this wonderful project. And you answered so many questions, but not every last one.
No.
Okay, great. Now we will go silent for just a minute while we prepare our next speakers. Thank you.
our next session panel with speakers Liana, Helene, and Ian. I'll let you all take it away.
Okay, thank you so much, Jess. I appreciate everyone's attendance here. I have been really enjoying WikiConference North America so far, and it's been great to also connect with the OpenStreetMap community. I am Leanna Davis, and I am the Chief Programs Officer and Deputy Director at Wiki Education, and we're here today to talk about how we're supporting 12,000 new student editors each year. So I want to introduce my co-panelists here. Helene, why don't you jump in and introduce yourself?
Sure. I'm Helene Blumenthal, and I am Senior Program Manager at Wiki Education, specifically for the Wikipedia student program, which is what we're going to be speaking about.
All right, and Ian.
Hi, I'm Ian Ramjan, and I am Senior Wikipedia Expert at Wiki Education.
This is Ian's third go-around so far, so you may have seen him and met him before. So today we're going to do, I'm going to do a quick introduction to Wiki Education's Wikipedia student program. And then Helene will talk about how we recruit, train, and support instructors. Ian will talk about how we train and monitor the student work. I'll talk a little bit about our impact to Wikipedia's content, and then we'll have an opportunity for a Q&A session. So let me dive in a little bit here and explain how our program works. So we at Wiki Education, we're at the top of this graphic, and we provide support to both instructors who are teaching with Wikipedia and student editors who are actually doing the Wikipedia assignment. So we provide teaching resources to the instructor. Helene will and Ian will talk about a little bit of these. And then to students, we provide the editing resources and trainings. The instructors actually teach the course, so they are going to teach the subject matter, and they will evaluate the student work. They are the subject matter experts on whatever the course topic is. We are not. We are instead the experts on Wikipedia and how Wikipedia works. The student editors do research, writing, gathering sources and putting together information about Wikipedia, and then the instructors are guiding the students in editing Wikipedia articles, and the end result is Wikipedia users get better access to information. So let me talk a little bit about the impact to Wikipedia's contributor numbers. So this was a chart from the Wikimedia Foundation's Metrics and Insight meeting a couple of years ago, where they were looking at the new editor sources on the English Wikipedia, and they mapped our participants versus every other new editor on English Wikipedia. And as you can see, as our program got going, it didn't really have much of an impact, but as we scaled up our program, the percentage of new editors coming from our program got greater and greater. And you see these spikes, they correspond with the start of the spring and the fall term in the academic year. And you can see at one point we even had more new editors coming in from our student program to the English Wikipedia than all other new editor sources combined, which is a really huge impact on that we have on English Wikipedia. In general, 19% of all of English Wikipedia's new active editors are coming from our programs versus 81% are coming from all of the other sources combined. And that's 9% of all languages and all projects. So the impact that this program has on Wikipedia and the Wikimedia world is enormous. And one of the really great parts and one of the things that I'm particularly most excited about is that the students we're bringing in are much more diverse than the existing US English Wikipedia community. So the Wikimedia Foundation's last editor survey last year surveyed Wikipedia editors in the United States and looked at race and ethnicity of them and compared them to the US population. And found the diversity to be quite lacking among the current US editor population. In contrast, our student program attracts a much more diverse set of race and ethnicity in our student population. Our categories are a little bit different because we offered a biracial, multiracial, or other chunk. So it's a little hard to precisely look at it, but the general trend line is we are doing significantly better at bringing more diverse students and more diverse editors to Wikipedia than exist in the current editing population. But we obviously have room to grow before we reach parity with the existing US population. And similarly, while only 22% of North American editors identify as women, 68% of Wiki Education students identify as women, non-binary, or another non-male gender identity. So with that kind of just overview of our program, I want to dive in and let Helene talk about how we do what we do. So Helene, I will turn it over to you.
Awesome. Thanks, Leanna, for giving that overview of the Wikipedia student program. So today I'm going to talk to you about three things: how we recruit instructors to teach with Wikipedia, how we onboard them, and how we communicate them throughout the duration of their project to make sure that everything is staying on track. To begin, though, how do we get faculty at institutions of higher education to run Wikipedia assignments? To give you an idea of how many instructors we're working with on a regular term this semester, fall 2022, we're working with 320 instructors who are teaching 363 courses among them, and 117 of those are new to the program, meaning it's their first time running a Wikipedia assignment. There's two sides to recruitment. So obviously there's getting new folks to join the program, and that's critical for the program's continued growth and expansion. But just as important is the retention of existing instructors. Returning instructors take up a lot less of our time. So obviously, because they've done it before, they're familiar with how to run a Wikipedia assignment, and we've seen that their students tend to do better work. At the end of each term, we assign each course that we support a course rating, and this rating is composed of a few different factors: how much time, how much staff time we have to put into the course, how much content the students add to Wikipedia, and of course, the quality of the content they add to Wikipedia. So then with that course rating, I then target my recruitment efforts towards trying to get those classes that had higher ratings to run Wikipedia assignments again. And I don't, on sort of the other side of that, I don't do active recruiting of courses that had a lower course rating. And if a course had a lower course rating and they want to, the instructor wants to teach again, we have processes to interact with that instructor to, ensure that the next time they teach with Wikipedia, they do, we tackle some of the challenges they might have faced. So recruitment is not just something that happens at the beginning of each semester. It's an ongoing process of engagement efforts that are happening more or less year round at Wiki Education. And I'll talk about some of those engagement efforts in a couple of moments. Okay, but then there's the new folks. How do we get new faculty to teach with Wikipedia? There's a number of ways that we recruit new faculty to join the program. And we're honestly experimenting all the time with new channels of reaching new faculty. We have two people on staff who are in charge of recruiting new faculty. Myself and my colleague Andres, who's not here today, who's our equity outreach coordinator, and he is specifically tasked with getting courses to tackle some of these knowledge equity gaps and tackle some of Wikipedia's diversity issues, as Leanna mentioned a couple minutes ago. So while I also focus on knowledge equity in my recruitment efforts, I kind of cast my net a little bit wider. Since the program's inception, the two largest sources of recruitment remain word of mouth and what we call visibility. And what we mean by visibility is, honestly, we don't necessarily know how the person came to us. So maybe they read an article in some publication, maybe they just found this through a Google search. But neither word of mouth nor visibility happens on their own. The former, word of mouth, happens because we provide instructors with a good experience while running their Wikipedia assignment, such that they share it with their colleagues and with their network. And the second comes about because we're really hitting the pavement all the time. We're pounding the pavement all the time, running workshops, having our instructors publish about their Wikipedia experiences, attending conferences, communicating on relevant academic forums, such that wiki education becomes a household name within academia. The pandemic, in many ways, opened up some new avenues of recruitment for us. As people became increasingly comfortable with virtual engagement opportunities, we started running more and more virtual workshops and webinars. And now we're pretty regularly running workshops on how to teach with Wikipedia virtually, where we get a lot of new folks to come and join. We do that alone. We also do that in conjunction with other faculty and other institutions. And we've also uncovered a wealth of listservs and various academic forums on Facebook that academics are using to find out about new pedagogical opportunities. And those have actually been very fruitful in terms of our recruitment efforts. So whereas my work is a bit broader, as I mentioned, my colleague Andres is specifically recruiting courses that are going to tackle some sort of content gap related to knowledge equity. So courses that deal with gender, race, disability, the global South. And his work is not just to recruit courses that are going to diversify content, but he's also trying to get faculty at more diverse institutions to adopt the Wikipedia assignment. So that means targeted outreach to historically Black colleges and universities, Hispanic serving institutions, tribal colleges and universities, and other institutions with more diverse populations. Because we're not just trying to diversify content, but diversify Wikipedia's editor base, as Leanna mentioned, which we're already doing, but we still have a long way to go. And obviously content, diverse content and diverse editors go hand in hand. So there's a lot of moving parts when it comes to recruitment. It means a lot of close coordination between myself and Andres. And we rely heavily on our database. We use Salesforce to manage our instructors. It could take several terms from when a person says they're interested in running a Wikipedia assignment to when they actually decide, okay, this is the term I'm going to do it. And that means a lot of careful record keeping so our communications remain smooth and relevant. It means a lot of mass mailing, a lot of responding to email inquiries, interacting on academic forums, and sometimes even hopping on a Zoom call or a phone call with a professor to kind of answer the questions they have about running Wikipedia assignment. So now on to onboarding. So recruitment is not just about getting somebody to say, yes, I'm going to do this. It's about ensuring that the course that they want to run the Wikipedia assignment in is actually suitable for the Wikipedia project. With more than a decade under our belt doing this, we've learned that not every class is actually suitable for the Wikipedia project. Every course we support goes through our course dashboard, and maybe Ian, you'll demonstrate that a little bit in your presentation. So they sign up on the course dashboard, they get a Wikipedia account. They then go through an orientation for new instructors that we've created, where we go over in more detail the types of support they're going to get from Wiki Education, some of the basics of Wikipedia policy and Wikipedia editing, and how to navigate the dashboard. After the orientation, they go through our assignment design wizard. This is where they tell us about the course that they're going to be teaching. They answer a series of questions, and then the dashboard creates a timeline or a syllabus, as it really is, for the Wikipedia project that best meets the objectives of that particular course. So I then review all the courses that come through, and I'm looking for a few key things to make sure that the project is going to start from a point of success. One of the first things I look for is the size of the class. We have a pretty strict cutoff at 100 students, that we won't support courses with more than 100 students. And even when we get to 50, I start getting a little bit leery, and I more or less very strongly urge / almost require group work when we get to more than 50 students. We've just seen time and time again, the Wikipedia assignment just doesn't work very well. In larger classes, we have issues with communications, and it just becomes too unmanageable. Another thing I'm looking for is duration of the project. Most of the courses we work with actually run for the duration of the term. We don't support courses that run for fewer than 6 weeks. This is to make sure that students have enough time to learn the basics of Wikipedia editing before they dive into main space work. Some other things I look for are subject area. We want to make sure students aren't getting in over their heads, and some other red flags that might signal to me, this course might not be quite right for Wikipedia project. But assuming I give the course the green light, I make it live on our dashboard for a particular semester, which then gets into how do we then keep track of and stay in touch with 350 plus courses a semester. We've developed a variety of processes and strategies internally to ensure that the courses we're supporting get the support they need, and more importantly, when they need it most. So there's a lot of mass mailing that happens for me, but more importantly, there's a lot of automated messaging that is going out from the dashboard to instructors on a regular basis. So as the assignment progresses, as they reach different points in the Wikipedia assignment, the dashboard will send relevant emails. So if the students are about to choose the articles that they're going to be working on for the project, the instructors will get an email talking about some best practices for finding an appropriate article to improve and how to start building out a good bibliography. If a course is working on biographies, they get an email about how to do that, talking about issues around notability. If the students are behind in their training modules, so we've created a suite of training modules to make sure that students can learn the basics of Wikipedia editing. And if the dashboard sees that the students are behind, an instructor gets an email alerting them to this so they can get back on track. At the beginning of the semester, we run an introductory info session where again we go over some of the ways Wiki Education is going to support the course. We walk them through the dashboard, and this way they have a chance to kind of learn to meet the staff who are going to be supporting their Wikipedia assignment throughout the semester. During the pandemic, I started running weekly office hours over Zoom, where instructors can pop in and ask questions, anything that they're struggling with. And these have proven incredibly productive, both for us and for the instructors. It's really helped to build community. In fact, a lot of times what happens is an experienced instructor who's at the office hours will help out a professor with a new instructor with a particular issue. And it's really given us a chance to kind of put our finger on the pulse of the program and to see what are some of the pain points that instructors are experiencing. We run a small mentorship program. So every semester, about 30 new instructors are paired with returning instructors who can provide them with some general support and pedagogical guidance. And again, this is another way we build community among our instructors. We have a lot of just proactive monitoring of what goes on in the classes, and I think Ian's going to talk about that in more depth. But generally speaking, we try to head off problems before they start, and we try to nip problems in the bud so nothing becomes too unmanageable. Finally, at the end of the semester, every course we work with gets a end of course summary email where we thank them for participating and we give them an overview of the work that their students did on Wikipedia. If they meet a certain threshold, they're given a Facebook link, a Facebook and Twitter link to share the great work that their students did. And so it's a really nice opportunity for professors to just be really proud of what their students did and share it with their networks. And it's also a nice little recruitment opportunity for us. So if their colleagues see this, maybe they get excited about teaching with Wikipedia too. And then the course is over and the process begins all over again. And with that, I'm going to pass it on to Ian.
You're muted, Ian.
Oh. I thought I was maybe silent the whole time.
No, I was trying not to interrupt Elaine. So okay. now I'm going to talk a little bit about how we do it, how specifically in two areas, how we train the students to contribute to Wikipedia, and how we keep track of what they're up to. So first thing is, how do we teach students to contribute? The key to just about everything we do is our dashboard. And this is the top of a dashboard page for a course. This course created 2 articles, edited 61, and had 50 student editors. So the key here, the key piece here is there are a number of tabs in here. This is the home tab, or this part of the home tab, which is an overview of the class. There's a timeline, a student tab, an articles tab. And in the timeline tab, we have a embedded timeline. We have a week by week process. So here in week 1, these were the dates, and we also have an overview here. So you can go back in time, you can see as a student what you were supposed to do, what you missed, what's coming up. And then we have these training modules embedded. So in week 1, here's an introduction, here's some additional resources. Now get started on these training modules, learn a bit about Wikipedia, take a plagiarism training because everybody needs that, and go from there. If you look a little further down, in this module so I mentioned the trainings already. There's a training module here that's designed to help students find an article to work on. There's a discussion module. This is a in-class thing that is completely in the hands of the instructor. But, here's a discussion for the students about what constitutes a content gap, what are you looking for, and then an exercise designed to help them choose a topic. So we have these 3 different kinds of things, and the students are prompted to do these on time, or, if they're overdue, they're prompted for that too. The training modules are slide-based. So if you click through to this, when they get to this how to edit one, and this is a little bit of an introduction to everything. So there's an estimated time to completion, and this is sort of give them a sense of what sort of time commitment. There are 19 slides, and then once they click through, there'll be questions, exercises where they're asked to try to make an edit, and many of these have questions to see, so quizzes built in to see where they're going, see if they learned anything. Once they've one of the important steps for them to work in our system is to use this assign an article module. So when they assign themselves an article, the dashboard knows what they're working on, and it sets things up for that end. This is a newer thing that so we used to just tell them to use their default sandbox, but now this lets the dashboard track much better what they're doing and helps us keep an eye on what they're up to. So once they've assigned themselves an article, they get a bibliography assignment, and it prompts them to find some articles and some sources, and to think about the quality of the sources. Very often, I'm sure many of you know, and if you see, when people want to contribute to a new article, be it a student, be it a editathon, whatever it is, they're often drawn towards working on something where notability is an issue, or finding enough sources to write a good article is an issue. And then students as a whole, younger people, are often drawn towards, and not just younger people, lots of people are often drawn towards the first thing that pops up on Google rather than the best source that's available. So the idea of the bibliography assignment is compile some sources, make sure that they're worthwhile, and then start drafting, expand your draft. And we try to to prompt them to move their work into main space in the correct way, depending on whether it's a new article, which about 10% of students work on, or an existing article, which is what about the other 90% work on. The bibliography assignment. So once they click that, it will give them some guiding questions. Is it a reliable source? Is it verifiable? Is it an independent source, primary or secondary? And obviously, you can't force people to go through these steps, but providing these prompts right in front of them is a good chance to get people to read them and make sure that they're picking appropriate articles. So in terms of getting them to learn Wikipedia, there's trainings, there's sort of a step-by-step in terms of drafting. But for us and for instructors, the other side comes in of how do you keep track of what they're doing? And going back to these tabs here, so I've looked at the home tab and the timeline. The students tab is one where the student's username pops up, the articles they've assigned themselves, their peers' work that they've been assigned to work on, and then the words they've added by namespace. So they should be drafting in their user space. They should be contributing in main space. If their work ends up in draft space, it's sometimes a red flag that something has gone wrong. So there's a lot of useful things here. For the instructor, you can see that they've completed or not completed their training exercises. I picked some that weren't so great. And so the exercises and the training modules. And if you click on one of these people's names, you then get a much more detailed view where you can see what they've done. You can see their draft, their bibliography. You can see what they've reviewed. And if you click on this article viewer link, you can see the article with the students' contributions highlighted. So this is another valuable way of seeing what they do, for instructors to assess and evaluate their work, for us to keep an eye on what they're up to. And the final one of these tabs to talk about is this overview where you can see the articles. This will be important if several students work on an article. You've got the same assessment tool where you can see their contributions to the article and things like words and references added. The third side, of course, is, as Helene mentioned, the importance of notifications from the dashboard. So the dashboard monitors students' work. When a student moves something from user space to main space, I get an alert. And it's a good way to see if they're creating a new article, if they've moved it prematurely, or if they've made a mistake and created a duplicate article instead of merging their improvements into the existing article. And it's a very useful thing that way. If a student assigns themselves a featured article or a good article, we will get a notification. They will get an email saying this mightn't be the best thing to work on, and the student and the instructor get that email. So it lets them reassign themselves. And when a student assigns themselves or edits an article that's subject to discretionary sanctions, again, we get an alert. Sometimes it's very helpful to point the student in a different direction. In other times, if it's since all of climate change is subject to discretionary sanctions on Wikipedia, if a student assigns themselves a climate change article and they're working in the climate change class, it's probably fine. But it is sort of take a look at what's going on, sort of heads up. And that's the end of my bit. So back to Liana now.
Yes, it's back to me. Thank you, Ian, and thank you, Helene. So as a recap here, Helene has talked a little bit about kind of how we recruit and support instructors in the program, and Ian's walked through a little bit how we train and then support students and the work he does to monitor student work. And so I'm going to talk a little bit about the work they add to Wikipedia, and then we'll have time for questions. I see there's a couple questions coming in already on the chat here. So one of the most common questions, I will just head this one off, is kind of why do we work with staff instead of volunteers? And the biggest kind of point about this is the sheer volume and the numbers that we're working with in the student program. As Helene mentioned, we've got more than 6,000 students are actively editing English Wikipedia right now. This is one of the busiest times of the term for us. All of the students tend to edit at once toward the end of the term. That's just the cyclical nature of the work that we're doing. And so there is large periods where there's not much happening, and then there's a sudden influx of students. And so what we're able to do is sort of make sure that we're providing support and make sure that we are monitoring student contributions in a much more standard way when we have staff support kind of in there to help, rather than relying on volunteers when they may or may not have time, or when volunteers themselves may or may not be busy. And since this term ends, we have a strong deadline, and we need to actually make sure that we're providing that support for the students and the instructors in that time period. So at the end of the term, the work slows down a little bit, and Helene mentioned we give a rating to each of the courses that we support here. We give a time rating of how much time we invested in the course. We look at how much content each student added in that course, and then we look at the quality of the content, and this gives us an opportunity to address any problems. Not every student writes good content for Wikipedia, and so it gives us an opportunity to revert student work if it is hurting Wikipedia and it hasn't already been addressed by the community. You will sometimes see us moving things back to sandboxes or just deleting content entirely. That is the work that we do to make sure that the content our students are adding is of high quality. And we'll look at sort of the quality ratings of each of the courses and evaluate kind of on the whole, did the students do excellent work, good work, or fair work? And then depending on kind of that rating, is there an opportunity to kind of do a little intervention with that instructor to bring them back up to a higher rating? Did they just make a poor article selection choice, for example, and maybe with more guidance around that, this course could do better work again in the future. So we do that. And as part of that, then we're looking through student work. So I wanted to show some examples. And Jess, if you could make that live here. So I want to flip through a handful of examples here of some student work from last term. So the first few here are all new articles that were created by students in our program. So this is an article on Thrastocytrids, which is part of marine ecosystems. And if you scroll down, I encourage you to take a look at this article. But this is an exceptional student work. They added images, they wrote lots of different paragraphs about this, gave lots of great information. And then when you scroll all the way down to the bottom here, you see all the different references that the students added to this article, which is a really impressive work that they did. This is, I would say, an exceptional article rather than a common article, but let me show you a few others that are sort of good examples of student work as well. So this was also a new article that was created this last term on the environmental impacts of the war in Afghanistan, which this is kind of surprising that this article didn't previously exist, especially given all the sort of attention the burn pit victims and things like that have been getting in the news. But that didn't previously exist. And so the student created this new article, added a few images of some of the that's an open air burn pit, for example, and talking about these kinds of connections between the U.S. foreign policy and the environmental impacts is an important topic to cover on Wikipedia that we hadn't previously covered. Another example of this is the California Racial Justice Act of 2020. So this is a great opportunity for students who are studying things like this to be able to jump in and actually create articles about laws that are being passed, and that not every Wikipedian will be creating a new article about things that are coming up. And so this is a great opportunity to get students who are studying this to make valuable contributions to Wikipedia. And so you can see this is a nice long article with lots of information and lots of sources again. But let me talk as well about some of the other kinds of additions that students make to existing articles. So I'm going to flip over here. This is the dashboard, and like Ian was showing the authorship highlighting. So this shows a biography of a First Nations woman that a student took that existed, and you can see they completely essentially expanded the stub into a much longer article and added lots of citations. Another example here, this is an article on the 2021 Kenyan constitutional referendum attempt. It was a pretty small article to begin with, and the student significantly expanded this, added images, added all kinds of information. And this is where this was an African politics class, and this is an example of how students who are working on this is one student's work, can really research and write long articles. Another example here is adding perspectives that are missing. So this is the example of the cornbread article, which up until this class worked on it, focused on cornbread's history in the Native American community, which is of course important, but cornbread also has an important part in the African American community as well. And so the section here, the student added all kinds of information about the relevance of cornbread in the African American community as well. So those kind of missing perspectives that students can identify and improve is also important. This is an example of updating an existing article. The race and ethnicity in the United States Census article has existed for a long time and has had all of these different sections of every time there's a census, how are the race and ethnicity updates handled? The 2020 census obviously happened 2 years ago, but nobody had edited this article to improve and add information about the 2020 census in it. And so these articles that look pretty well developed and have lots of good information can become outdated on Wikipedia. And this is a great opportunity for students to come in and add timely information for something that happened but that hasn't been updated. And then finally, the last example of student work I want to give here is this is actually a featured article on one of Jupiter's moons. And the student had found, we tend to encourage students not to work on featured articles, but the student was in a planetary science class and actually found new research that had come out that hadn't yet been incorporated into the article, and no one had touched it because it was a featured article. And so the student was able to go in and add this long section that probably should be broken up into multiple paragraphs, but at least added information to a featured article. So this is an example of when sometimes students are actually able to add good content to featured articles as well. So I know we are I want to leave a few minutes here to answer any questions. So I'm going to stop the sharing of the screen right there. And then let me pop over and take a look. I know we had a question originally of how many of the new editors ever contribute to Wikipedia following the class. I'm happy to answer this question. So a handful of the student editors will go ahead and continue editing. The vast majority of them will just take a second class that has a Wikipedia editing component. And so they will continue to edit because they're writing another article for a different class from the same professor or from a different professor at their university. But we don't really focus on this. The goal of our program isn't to increase the retention of student editors. Our retention efforts are focused on the faculty members instead. That's what Helene was talking about. What we've found is that when we recruit a instructor who's incredibly dedicated to teaching with Wikipedia, they can bring 20 or 30 new students each term for years and years and years, and they get really good at teaching with Wikipedia, and the content quality of the work that students add after someone has been doing this for a long time is incredibly high. And so what we've found is that there is more value in working to retain the good instructors so that they constantly bring a fresh batch of students who are working on that content area to improve Wikipedia in that area. And then Jim asks if there are edit quality metrics such as ORES, above word, and reference count. Yes, let me actually see if I can show you this. Oops, I need to present a screen again. I am sorry, Jess, I'm going to ask you to put this up again once I get it going here. Okay, so this is an example. If you click on what I did here, let me back up. What I did is I clicked on, this is the fall 2022 course term. This is the current term. I clicked on the first one, the one that's most active right now. If you click over to the articles tab right here, you'll be able to see all of the articles that the students are working on, and you can click this button that says change in structural completeness, and this actually does pull the ORS scores for all articles. So there's the score before and the score after, and you can adjust this. You can include both new or existing articles and minimum bytes added and minimum change in score. So if you're looking for articles that just that the students are adding a sort of significant number of words, or if you're looking for a specific kind of increase in score. But as you can see, the student work sort of goes across the whole spectrum here, right? Of, how many how much content or how many change in the ORA score does an article have over the course of student work. Some students do very little, and some students do quite a lot. But you can see sort of the continuum here of those.
Between the purple and the green, which is new and which is before and which is after?
The purple is the before and the green is the after. So yeah, and this is for this particular course level, and there's also a way to look at this as well from an entire term perspective, which is what we tend to look at, of kind of how many articles are we supporting that are having a significant increase in article quality. Are there any other questions that I can answer, or Helene or Ian can answer? I know the live chat is a couple of minutes behind where I am, so I'm looking at my other screen here to see if something else is coming in. I'm not seeing anything else come in. We've got a couple more minutes here. So what I will just do is plug of, if you're interested in getting involved, we are always looking for new faculty who want to teach with Wikipedia, especially anyone who is teaching in those equity content areas that Helene mentioned. That's something that our organization spends a lot of time working on. And so if you are familiar with somebody who is a college or university instructor in the United States and Canada and is interested in potentially incorporating a Wikipedia assignment into their class, they should reach out to us. Our teach.wikiedu.org website is a great opportunity for them to learn more about our program, and you can either just jump right into the dashboard, and that'll give you an opportunity to go through our new instructor orientation and our assignment design wizard to actually create your course page based on the learning objectives for your course. Or if you if you're interested in just signing up to hear more information, Helene mentioned all of her Salesforce lists that she's constantly sending out messages to. There's an opportunity on that page as well to sign up to get more information about deadlines for forthcoming terms. And Helene, what's the deadline for the, I know you're in the middle of recruiting for the spring term right now. What's the deadline?
December 16th.
December 16th. Yeah. So if you know someone who is interested or might be interested in teaching with Wikipedia, on December 16th, they've got another month to submit a course page for support in the spring term.
I think we're over time.
Okay. Thank you, everyone.
Thank you.
Well, thank you so much. And Liana, Helene, Ian, feel free to go back to Hopin and answer any late coming questions in the chat.
Great. Thank you.
Thanks, Jess.
Okay, we're actually going to just transition straight into our next speaker. So I want to pull up Denny.
Hello there.
And the floor is yours.
Okay. Hello. And so, yeah, thank you for having me here. I'm really happy to be here and to give this presentation. It is great to see the Wikimedia community and the OpenStreetMap community coming together. And I've seen the agenda, and I'm talking in parallel to a presentation on tools for connecting OpenStreetMap and Wikidata, and a presentation by Rosie Stevenson-Goodnight, and left to see both of each. But thank you for everyone who actually came here to see this one live. I'm honored, and I'm looking forward to catch up on the recordings myself. And I'm Danny Vraničić, Head of Special Projects at the Wikimedia Foundation. And today I want to introduce you to a new project we are working on, WikiFunctions. As you may know, the vision of the Wikimedia movement is to imagine a world where everyone can share in the sum of all knowledge. So what will WikiFunctions do in this role? WikiFunctions will be, in short, a collaborative library of functions for everyone. Usually this explanation leads to even more questions, such as, what is a function? Mathematically, a function is a mapping from elements of one set to elements of another set, but this might be technically correct, but usually doesn't explain much. It is easier to see a function f, for example, that's something that takes some input x and transforms it predictably into an output f of x. It is some form of process or calculation or transformation. But when I say calculation, I don't really mean just numbers. You know, it could be, they don't have to be. It could be geocoordinates, it could be colors, it could be ingredients, and they can then be, when you have a function that turns like two numbers into a sum, like for example here on the right hand side, or that takes two colors and mixes them together to see what they come together, or takes two ingredients and does something with it. So all of these are functions kind of to tell you what they are. And that's also where we get an idea that functions don't just transform an input into an output, but they actually answer questions, if you think about it. They answer questions like, what do I get if I mix red and blue? And you get the answer purple. And something that answers question, well, that's knowledge, right? Functions answer questions. Functions are knowledge. And the big tech companies know this. And they have been using functions to answer your questions for a while by now. We have, for example, here Siri answering the questions, how many teaspoons are in 2 tablespoons? And you get back 6 teaspoons. The answer is calculated by a rather simple mathematical function. Or here we go to Microsoft Bing. We answer the question, when was OpenStreetMap founded? It uses a large knowledge graph. It uses the web corpus to answer this question. Or here the question to DuckDuckGo, when you ask, how far is it from Cambridge to Berlin? And it will tell you, oh, it's about almost 13 hours, 726 miles, just in case someone would like to know. And this here is my favorite answer to a question, and with including a function. If you ask Google for the volume of a pyramid, it gives you this really beautiful experience. It lets you enter the free As you enter the three relevant arguments, the length, the width, and the height, it highlights in the sketch which one you're entering right now. It substitutes the values that you just have given in the formula. You see the bottom, you see the formula, and then it calculates this and provides you with a solution. This is a beautiful educational and immersive experience using a function to answer your question. But here's the one thing. You get this experience only for the functions that some team at Google or DuckDuckGo or Bing or Siri, Apple, thought is important enough to answer for you, that they think that it's impactful enough to have been answering. There is no way for you to suggest a new function, to implement a new function, to create a new type of experience like this, to give more people more answers for things they care about. And as soon as you move outside of those carefully engineered experience, for example, how do I reverse a string? Well, you can, in Google, you get back to the 10 blue links, and that's it. This is a pretty simple example, like reversing string. There is code inside of Google that knows how to reverse a string, but there's no way that you as a user can trigger that experience. And if you're lucky, and you go to one of those 10 links, you might find, some old website that provides some JavaScript implementation that's full with ads, might have a lot of tracking. You don't know how reliable it is, and it might be pretty heavy on the browser doing all the calculations in there. Or you might find something that's pretty out of date and rather old, but it does the calculation. And you'd think, reversing a string, that's such a simple thing. But look, even if you find in Stack Overflow, you'll find literally dozens of discussions about this. And if you go to GitHub and look for the code, you will find a few that are rather quite wrong. And even simple task gets wrong. This is a lot how the web used to be. Like, we had a lot of different websites, each with little nuggets of knowledge. And then Wikipedia came around and started collecting the sum of all this knowledge in one space and started to give rather common layer of quality to all of it, with thanks to the editing practices on Wikipedia. Now, imagine a directory of functions, a library of functions, with the implementations, documentation, tests for them. This is something that might be helpful for a lot of people, and not just developers, but basically for everyone who wants to answer more questions. Where we have a function doing something, they all tie together in one place, no one's tracking you, there are no ads on it, and you don't have to implement the things over and over again. And just to give one example, so I went to GitHub and looked for functions to calculate how many days have passed between two dates. And within the top 40 results, more than half of them were wrong. They got the leap years wrong usually. They either forgot the 100-year rule, the 400-year rule, or they even forgot the 4-year rule sometimes. So there's so many things that are just wrong. And if you think, those things happen only in in this open source projects that no one cares about. No, they happen in productions just as well. About 10, 15 years ago, I got locked in the parking garage at 3 a.m. at night because the machine checking my ticket didn't understand the switch to daylight saving time and thought I was in for too long. The world needs so much code, so many functions, and so many of them are written again and again and again. And so many of them are buggy or have problems with some edge cases. And it's the edge cases that hurt underrepresented people the most. We want to collect those functions in one place. We want to provide a good catalog of functions, a large library, because these functions are useful. They answer questions, and therefore they are knowledge. And as knowledge, well, they fall under the mission of the Wikimedia movement, directly into the mandate of what we're trying to do. But that's not all. So functions are knowledge. And knowledge really is power in this case. And it's not just power, it's actually a superpower. Because, unlike a Wikipedia article, they don't just answer the questions that the text has an answer for, but a function can be used to answer a question no one in the world has ever asked before. And that you will get a reliable, trustable answer to that if you trust the function. So imagine that you can ask a question that no one ever has asked before, and you can be confident to get a correct answer for that question. It's pretty cool. It's pretty amazing. And I really think that this is a superpower. We don't want to be granted and taken away by big tech companies. We don't want some teams and those few companies to decide which of those functions we should have access to and which not. But we want to have our own library of function that we work on together, that any of one of us can edit, can contribute to, that any of one of us can use. And this is why we're working on WikiFunctions. This is what WikiFunctions aims to be. In WikiFunctions, each function will have a page. So this might be, for example, this might be something really simple, like for example, the add function. It takes two numbers and returns a number, which is the sum of those. What I'm showing you right now are screenshots of our current beta version. To make it very clear, we are working very hard on designing better user flows, better user experience, and I just have seen some major design updates this week, and I honestly can't wait for them to be implemented. It'll be so much easier to use and so much easier to understand what's going on here. But for now, bear with me with the current beta. So what we see here is a page for the function add. We can enter two values on the right-hand side, for example, 3 and 4, and then we click on call the function and we get a 7 back. Now, not particularly amazing, I know, but it works. And let's take a look at the details pane of this function. So here we see some of the machinery behind what's going on with the function. We see the function definition on the left-hand side. It says, well, we have two inputs. Input 1 is an integer. Input 2 is also an integer. And what you get back is an output integer. It's a positive integer. And you have names for those, for the inputs. And we see here a list of implementations on the right-hand side and a list of test cases. We'll get to both of these in a moment. So we can have then, for example, a function like tablespoons to teaspoons. That's the one that we used earlier with Siri. And it's not particularly complicated, it just needs to multiply with 3. And here, let's talk about the tests now. So we see there are two tests in this case. 1 tablespoons are 3 teaspoons, 2 tablespoons are 6 teaspoons, and this is being then checked against the implementations. The tests fulfill a number of functionalities. On the one side, they're making sure that the function actually returns what is being expected. On the other side, the idea is that the test cases, the example cases, can be written by folks who don't necessarily know how to write the actual code to implement them. So we can have more people interviews and making sure that the function gives you back what you're actually expecting to get back. And also they provide examples on how the function can be used and what the results would be looking like. Let's take a look at another example. We're getting now to reversing a string. Here we see some input ABC and returning CBA in this case. And let's take a look at how this is implemented. So what we see here, that's we're taking a string as an input, we're returning a string. Here let's focus on the implementations as promised now. So this one has 3 implementations. That's something that we usually don't see much in programming systems. Why do I need several implementations for the same function? The idea here is, and there are again a number of reasons for that. So for example, if we have several implementations, the system can actually select one that, for example, takes the least resources to run. That's the fastest, or that's cheaper to run for some other reason. So we can just optimize the system a lot and don't have to go for everything. We don't run them in parallel. We just like choose one and run it. The second reason is that we can be more robust against vandalism and against attacks, because you have to go and change all of those implementations who might be in different programming languages, and you have to make sure that they're all re-included very quickly. So it's kind of difficult to do malicious changes here because of the fact that those different implementations integrate with each other and with the test cases at the same time. You can also avoid edit wars. So if for example, if you have contributors who don't agree on which algorithm for a specific function would be the fastest or the best, you can just record them all Similar as we have in Wikidata, the ability to record contradicting information. We just record them all, and the system will decide which one to use based simply on how much on its previous experience with running those functions. So we can take a further closer look at the functions as promised. For these three implementations, let's go for the first one. The first one is in Python. Here again, the code doesn't look particularly idiomatic because of the names of the identifiers. This is something that we are still working on to fix. But other than this, this is pretty standard Python. I wouldn't claim it's exactly the easiest Python, but that's just how you would idiomatically do a reversion of strings in Python. Then we have the same thing for JavaScript. A bit more complicated. There are several ways to do this in JavaScript. There are several ways to do it in Python. Here's just one. It splits the string into an array of characters, reverses the array with the built-in reverse function, and then pulls them together again to a string. But I think those two implementations show why even something that seems so simple, like reversing a string, would generate so many answers on Stack Overflow and so much discussion and so on, as we saw before. And in both of those programming languages, there are many other ways to reverse a string. It doesn't have to be this rather compact ways that we saw here. It could also be a for loop or whatever. There are many, many different ways. But the important thing, you as a user of WikiFunctions, you don't have to worry about how this is happening in the background. You can just call the function and it will automatically use one of the implementations that are available. Here's another function, a more specific one. So this function, it's called replace a y at the end with IES. So what it gets a string and a word in that ends in y, and then it takes the y away and puts an IES in it. You can see with the examples, it, for example, turns daisy into daisies. So this is one form of creating a plural in the English language. If you end with a consonant and y, then this rule can be applied. The implementation here is using something called composition. Now, composition is not a brand new cool program language you haven't heard about yet, but rather composition is just some WikiFunction way of composing existing functions together. So what replace y at the end with i's does, there's another function called replace at the end, and that takes one argument and then an argument what is to be removed and what is to be added. And here we have basically hard-coded the y for to remove and the IES for to add. So we are using just saying, okay, use that, use this function replace at end, call it with those two arguments and pass the first argument through. And that's it. In order to create this function, you don't have to, there's no coding required at all. You just do this basically in the user interface. You click and pull them together, and you get this function back. So you don't need to really do any coding. And there's we do another trick that we also learned from Wikidata. Every page has actually a numeric set ID. You see here at the top, for example, this is set 10, 20, 240, 10240. And then each of the pages can have labels associated with them in different languages. For example, here we see this one has English and German labels. And what it means is that we can switch the whole thing to another language. And what we see here now is the composition, basically the implementation of the replace y with IES function, but in German. You can then read any of those compositions in your own language. You can develop those compositions in your own language. You don't need to be able to speak English in order to do this kind of implementations. You can use these functions as a German speaker. You can implement this function as a German speaker. And you can share it with an English speaker who will just as well understand it because it's the same structure, just using English labels. And in any of the other languages we have supported it, we have labels for. You will be able to compose function implementations in more than 300 languages. We'll talk about this a bit later, but for now, let's change the topic entirely. And let's go to geodata, both in OpenStreetMaps and in Wikidata and Commons. I don't think I have to talk much about OpenStreetMaps. You had the keynote yesterday. You know a lot about this. OpenStreetMaps has geodata figured out. It provides a high quality map of the whole world, and I'm so happy to see those two communities here coming together, because there's so many touch points between the Wikimedia community and the OpenStreetMaps community where our data really can benefit each other. And I'm looking forward that we're talking and collaborating much more. Wikimedia also has some geodata, but nothing compared to what OpenStreetMap has. And I mean, it's kind of intentional. We are not competing in this space. We are just doing some complementary things today. So, for example, if we go to Wikidata, and we see how many political entities, just as here for the country of Brazil, we will have some geographical data. So at least some coordinate or whatever, sometimes more. Here for Brazil, for example, we get the geo coordinates of the extreme points, what's in the easternmost point, the southernmost point, etc. But we also get a link to comments here with the geoshape property. And then in comments, we have an actual geoshape stored, and see, oh, this is a geoshape of Brazil, which is then available in comments. What we also have in Wikidata is a link to the OpenStreetMaps relation via its ID. And if you click on this, you also see then the map of Brazil based on the OpenStreetMap, inside of OpenStreetMaps, and based on this relation. Hopefully, the relation of OpenStreetMaps and the one in comments and Wikidata comments are reasonably the same with each other. So having this kind of geoshapes in Wikidata and comments allows us to ask all kinds of questions to the Wikidata query service that do not work directly within OpenStreetMaps. You can't ask directly in OpenStreetMaps. For example, what you see here is this is just a query to the Wikidata query endpoint. All the countries in the world that have a female head of state, and then the country being highlighted. This map changed quite dramatically recently. Here's a map of all the countries with a female head of government, according to Wikidata. And again, this is based on the shape files that we have in Commons that are loaded and being displayed on OpenStreetMap map overlaid over that one. So, and if I understand it correctly, Wikidata goes beyond some of the limitations of OpenStreetMap. That's, for example, it gets here it gets into the space that, for example, historic OpenStreetMap maps. In Wikidata, we have a lot of entities for historical countries, historical provinces, like the province of Ragusa, which used to be an Italian province, and then we have also a shapefile for that historical part. That's something we have, but not particularly a lot. So. This is something where we probably with historical streets we should use also relation IDs, be able to link to those and see what we can do and connect. Other things that we can do is, for example, to connect the biological taxon, like a species, with a map of where the taxon lives, with a distribution map. So, for example, this here is a page on Wikidata of the aptly named Alabama map turtle. And for the Alabama map turtle, we have then also a link to a shapefile on Commons, where we can then see where does the Alabama map turtle live, like what are the areas that they're on. The geodata on Wikidata is really very spotty currently, but there are a few really nice ideas what we could do if the data was more complete. I would hope to see that we have someday many more taxon maps, historical countries, ecological areas, climate areas, etc., connected in Wikidata or in OpenStreetMaps or in historical streetmaps, connect each other so that you can use all of these things. Because then what we can do, and now I'm tying the two topics of my talk together, we can use functions for geodata. Very much looking forward for how wiki functions can then be a growing library of functions for Wikidata. Having these functions has the opportunity to expose the geodata on wiki functions, on OpenStreetMaps, and so on, much more to the wider world, to answer questions on it, to make it more prominent, to create an incentive for why the data should be more complete, more comprehensive, to use it more. And following the old rule that only used data is good data, meaning that it will be checked for correctness, for completeness, it will be kept up to date and so on, functions will hopefully fulfill that task of making it more used, more visible, and therefore also more needing to be updated and asking and be more beneficial to be updated. So here are just a few quick mock-ups of how things could be looking like in the future. And things where the geodata community probably already has libraries, in Python or in JavaScript or whatever that you use for exactly these kind of things. But now I want to make accessible through WikiFunctions to a wider area, to a wider audience that doesn't have the need to actually download a development environment or whatever, can just run those things from the browser. Make it easier accessible. So for example, we could, like, given a geoshape, calculate the area that the shape describes. Or we could, given a geo-coordinate and a shape, we could ask whether the coordinate is actually within that shape or not. Or we could, given two shapes, calculate if the shapes overlap, if they are in intersection between two shapes. And even with just these three functions and the right data, we can already answer so many new questions. For example, we can ask, does the Alabama map turtle, can it be found in Texas in the wild? Or we can ask, well, do polar bears and penguins ever meet in the wild? We can ask if the Roman Empire extended into today's Sudan. All of these questions can be asking many more like these. We can also use those functions for quality checks. We can ask, for example, is Germany covered by all of the 16 German states that we have in Wikidata and shapes that we have? Does the size of the area described by the shape of Ohio correspond to the size of Ohio as recorded in Wikidata? Are all the cities of a country located within that country? And many other things. So we can find easier, like, things that look weird, that look off, that can be, and then check it and put it on a list for someone to take a look, and they can have some confidence that the other things at least are consistent. We can't obviously check for correctness, but we can check for consistency. Rich and comprehensive geodata is really awesome and makes a few functions into the story. We become so much more powerful at doing things, at answering questions, at ensuring that our data is consistent. We can discover errors easier. We can answer more questions than ever before. So, switching topic again, changing away from geodata, the main motivation for WikiFunctions, for the Wikimedia movement, for the Wikimedia Foundation, and engaging in this project in the first place is not about geodata, I have to admit, even though geodata, I said, is really, really cool. It's about natural language generation. You will soon see why. So in WikiFunctions, we are hoping that we will have many, many functions which are very useful to have, for example, for natural language generation. For example, in most languages in the world, it's useful to have functions that do inflections on the word. It gives you the right form of a word like april, the past tense, or some verb bound to a case, and so on. To give a simple example, with a bit of trial and error, you can come up with a function that creates plural of an English noun by being correct in like 98% of all cases. So we could have such a function, for example, in WikiFunctions, and the rest would then be the regular forms. This is, by the way, how we can use the replace y with the IES at the end function that we have seen before. And this doesn't only work in English, this is true for many languages. This is why it's so important to allow non-English speakers to create these functions, to implement these functions. Because for many languages, we simply won't have enough people who know that language well enough to create these functions, because you don't just speak the language, you have to actually have some linguistic understanding of the language, and who know how to program, and who also speak English and can then contribute to an English-speaking interface. Those unicorns who combine all these three conditions are also usually in high demand and will hardly have the time to contribute to a Wikimedia project. But our goal is to decouple the need for these skills in a single person, but rather to have them across different persons, to have them a set of community, where people with different skill profiles can collaborate. One person defines the need for a function, another writes the examples, it tells like, oh, these are examples which work, and then, oh, it didn't work for this one, let's enter it. They create tests. A third one then composes an implementation in their language, and we have a chance of creating the world's most comprehensive natural language generation library, covering hundreds of languages. And we start from individual words and their forms, like we have just seen with the plural for English, and we can then generate whole sentences, just as here, for example, a statement of birth. We give a person name and a place name, and then we get a sentence like Albert Einstein was born in Ulm. And this eventually then will take us to a place where we can generate whole paragraphs and even whole texts. This, what you see here, is a prototype implementation. It has been done by the Google Fellows that have joined us for the last half year. You see the English and the Hebrew output from the identical content function call. And so they both use the same content. And they generate this whole paragraph of text. And yes, it's not, the prose isn't as great as like reading the Wikipedia article, but it's certainly not too bad. It's readable, and you can imagine that if you don't have anything about Marie Curie, this is still a huge improvement, gives you a lot of information about. But again, the texts are generated from the same abstract content. So if I change something in the content, like the year when she received the Nobel Prize in chemistry, and correct it from 1909 as it is now, correct it to 1911, like here, it gets automatically updated in both of the texts. And it remains in sync. So the content in both of the texts are always the same. You see here we have 1911, both in the Hebrew and the English. We didn't have to manually propagate it into different languages. The natural language generation functions take care of regenerating the text from a common abstract content. And this is what we need in order to build a multilingual Wikipedia. This is our main motivation for creating wiki functions. To create a truly multilingual Wikipedia, where you have to create and maintain content only once, and then have functions that generate the natural language text from that content in a lot of the languages that we want to support, in order to fill the gaps that currently exist in smaller Wikipedias. So we can here see them. There has some content, for example, stored in Wikidata. And then in WikiFunctions, we have a function that takes the content, turns it into natural language, like here, for example, into English, and returns into a sentence that can be used in the respective Wikipedia. If the Wikipedia so wants to, if there's a gap, if they notice, oh yeah, we need this content, they can just take it from outside Wikipedia. And be knowing that it will get updated and maintained inside of outside Wikipedia. We can now change the function from one language to another. For example, I just changed the function to the English one, to a Croatian one, my native Croatian, and you see the result is in Croatian, and we can use this now in Croatian Wikipedia. But the content is entirely the same. So the content and the functions are completely separate from each other, are maintained independently, and so we make the content available in all those different languages. To be clear, this is not meant as a replacement for Wikipedia, not at all. We will never get to the place where text generated from abstract Wikipedia can beat human-written, human-crafted text in terms of readability, fluency, and so on. But in many cases, it can fill out the gaps that currently exist much more efficiently, much more effectively, increase the correctness, and have better support for and be better to be up to date. As I said, I don't expect the resulting text to be great prose, but I hope it will be good enough to bring more knowledge to more people in their own language, and to allow, which is even more important, to allow more people to contribute their knowledge in their language to a common baseline of knowledge for every language to be available. And this is why we need WikiFunctions as a new project for the Wikimedia movement. But nevertheless, wiki functions will not only work for natural language generation functions, but for all kind of functions, as we have seen with the geodata examples. And I'm looking forward for examples in music, in the sciences like chemistry or physics, in mathematics, in art, and so many more where we can use functions. To summarize, wiki functions aims to democratize access to functions. Today, programmers have easy access to all kinds of functions, but others who are non-programmers have only whatever big tech usually allows them to have, or whatever they have access to through certain apps and so on, but they can't just go ahead, create their own functions, use their functions easily. With wiki functions, we want to democratize the usage and also the creation of functions. One way to democratize access to functions is to allow for people without English language skills to use functions, to create functions, to implement functions. We think that there's a large pool of potentially highly skilled contributors who have all the skills necessary to contribute functions but don't speak English, and we hope to unlock their potential. We want to provide a massive library of functions for programmers. Functions that have been community vetted, that are widely used in many different areas, that are correct. I'm looking forward to a world where no
Hi, everyone. Apologies. It looks like we lost Denny's connection. As soon as we can get him back on, hopefully we can give him a few minutes to wrap up and answer your questions. In the meantime, please sit tight. We will also have a great session here at the top of the hour. Thank you.
All right. I hope we are live right now for WikiConference North America 2022 and Mapping USA. Welcome everyone to the final session for today. We're really happy to have this session as part of the Greater Wikidata at 10 celebrations. So my name is Andrew Lee. I am a longtime Wikimedian, and I currently do work with the Smithsonian Institution in the United States as the Wikimedian at large. And each of our panelists will introduce themselves later on as we talk about Wikidata. If you are interested in the slides here, there's not a lot of them, but you're welcome to browse them at bit.ly/WCNA2022-Wikidata. And there's also a QR code there. And feel free to type into the chat anything that might be interesting to ask us or to comment on. And let me see if I can advance the slides here. Great. So here's our panel for today. Again, we will be introducing folks later on individually, but we have Phoebe Ayers from MIT, longtime Wikimedian and previously a member of the Wikimedia Foundation board. We have Min Nguyen from both the Wikimedia side and OpenStreetMap side. And we also have Richard Welty, who is working on Open Historical Map. And we were going to have Denny before, but you just probably heard from him already. But the good news is I can point you to a talk where he talks about Wikidata at 10 at length. So we're going to talk a little bit about the Wikidata basics. There is some interest in folks who may not know a lot about Wikidata to just get like a 5-minute tour of what we're talking about. And it'll make a lot more sense when we start discussing Wikidata if you have some grounding in some of the concepts that we're talking about. And then I thought it'd be interesting to look at some of the Wikidata celebrations around the world. And then we're just going to have kind of a roundtable discussion of folks who are assembled here to talk about some of their kind of aspirations or hopes for Wikidata for another 10 years. And we're more than happy to have you folks in on the conversation as well. So Wikidata celebrations. Let's first take a look at this. This is the video that the Wikimedia Deutschland folks who run Wikidata made. And I hope we can hear the audio on this. Please put in the chat a message if you cannot hear this, but this is the really nice intro video that's only about 4 minutes long.
I feel like doing a happy dance because today Wikidata is 10 years.
This is birthday love.
For 10 years, people have been adding content on Wikidata, building this website and making it one of the biggest knowledge base under free license on the internet.
I have not only contributed, but I have learned a lot of amazing things and also amazing skills.
The information that is there, I can be able to process, collect, and use it.
When you're looking for an information and you use Wikidata as your tool.
Your imagination is your limit. You can do so many things that was not possible before.
Wikidata brought a lot of change to Wikimedia and the movement. Most notably, it brought us closer together.
Wikidata enables everyone from every communities to contribute on it without having the language as barrier.
It is an amazing achievement that this project has really allowed for multilingual collaboration in the most meaningful way we could imagine.
We can summarize knowledge in this one place, and then we can make it more accessible to everyone else.
There's a lot of potential for Wikidata within the Wikimedia ecosystem and outside of it.
Because the data we have is very, very useful, not just for Wikipedia.
So Wikidata is the information backbone of Open Arts Browser. And the related data linked from Wikidata, like Wikipedia articles or Wikimedia images.
And data is even more powerful and useful when it has context, when it's linked together. And that's why very early on, we decided to link Open Food Fact, Wikidata, and associated projects like Wikipedia.
Thanks to the Wikidata community, the Gov Director can make the online presence of every public organization easily findable, queryable, and trustworthy.
The community is really what makes
Wikidata special. They just really care about some aspect of the data and want to ensure that it's modeled correctly and has accurate and comprehensive data.
People who care about providing the world with knowledge.
The impact it has on the society, the openness, having access to free, open resources.
I'm glad to be part of those that contribute to free knowledge.
We are all involved in this. We are all happy about this, and we will all continue to work on this. Thank you.
Feliz aniversário, Wikidata!
Kami, komunitas Wikidata.
Felice Andaskijaton, Wikidatumor.
Thumbs up, Wikidata.
Happy birthday, I wish you millions of pleasant items.
1, 2, 3,
Keep doing what you do best in linking our structured data.
Have a blast.
Off to the next 100 years and what we will achieve there.
Happy birthday, Wikidata!
All right, so I don't know how many people have seen that video. I only saw it for the first time today, so I was really impressed and inspired by that. So that's great to see. If you want to, if you want to see that, you can go to the YouTube channel for that. And if you want to see more information about the 10th birthday, you can go to the Wikidata page for the 10th birthday there. There's also a whole category just for Wikidata cakes, which you could probably take a look at later if we have time, but feel free to take a look at those. If you are interested in a more extended conversation about Wikidata, there was a conversation I had with Lydia and Denny of Wikidata as part of Wikimania earlier this year. So there's a 30-minute session, but also an extended conversation there, and you can reach those at those two YouTube links that you see there. All right, so I was asked to say, could we summarize Wikidata in 5 minutes? Is that even possible? I don't know. I'm going to try to give you an overview of Wikidata in 5 minutes and see if we can give you some kind of taste of how to understand structured data and the impact that we've had in the last 10 years. So let's go and take a look. So if you're interested in all this information in one page, I would recommend this one, which is a page available now in 10 languages. I believe maybe it's 11 at this point. So this is trying to boil down all the main Wikidata concepts into one page, and even have links that you can click off into the exact wiki pages from the PDF file. So this can be found under bit.ly wikidata-1 page, or there's a w.wikilink/m5. That's a really nice shortcut there, M5. Now, if there's only two things to remember about Wikidata, there's a lot of things that you can remember about Wikidata, but there's two things, we're to simplify it maybe, is that it's a realization of the semantic web, which is kind of the original vision of Tim Berners-Lee as the creator of the World Wide Web. And just think of it as, how do we structure the data rather than just having it be words on a page that you might see in Wikipedia? Sometimes folks who talk about this say, we're talking about things and not strings, right? Not strings of text. We want to actually know about what is underneath those strings. Another way to see it is to turn human readable stuff into machine understandable things. Another thing that you'll also have people talk about with Wikidata is the power of linked data or linked open data. So it's not just that we have this database of things, but we actually know how to map this thing to what the Library of Congress thinks is the same thing, or the Smithsonian, or the Louvre, or other entities around the world. And that linking to external databases is a huge reason why Wikidata is so popular today. So those are two basic things that you should probably understand about Wikidata. So an example of what this actually means underneath the surface is that Wikidata is what we sometimes call a triple store. Now, that's kind of a weird name, right? It's basically a database that stores three-part statements. And what are these three-part statements? Well, they are basically in the format of something has a relationship to something else, right? So for example, we're to say, who is George Washington? We can say George Washington is an instance of a human being. Okay, it sounds pretty basic, but in the database, we want to know whether something is a human, a book, a movie, something, right? So the most basic thing we have is an instance of human being. We also might want to know more things about George Washington, like where is he buried, right? So George Washington, place of burial might be Mount Vernon. And then we also might want to say, well, there's lots of George Washingtons in the world. How do we know the George Washington we're talking about is the one that is the same as the historical George Washington everyone knows about? And we might want to link to a database like the Library of Congress. And the Library of Congress has a very extensive set of biographical records. And we can point to the one in the Library of Congress, which is what you see the third one here, what we call the LC Auth ID, or the Authority ID at the Library of Congress. And they have a unique identifier for George Washington, the first president. And this is what makes Wikidata so useful, is not only do we have our stuff in Wikidata, we've now anchored our item to be the same as this at the Library of Congress. And that is sometimes what we call authority control. So we've turned now a sentence like President George Washington is buried at Mount Vernon, Virginia, into all these different statements that we have in Wikidata. So why is this useful? Well, it's useful because we can do all kinds of cool stuff like this. So the technical term for these kind of databases is what we call RDF databases. But basically, we are storing all these statements in a database, and we can actually start to see relationships here, right? So Edward Hopper is a painter, but he's the creator of these two paintings here, Cape Cod Morning and Nighthawks. And Nighthawks is an instance of a painting, and the painting is a subset of a creative work. And Edward Hopper was a citizen of the United States. And so you can start to see how this is kind of like 6 degrees of Kevin Bacon here in terms of facts that are stored in Wikidata. And the benefit of this is that we can kind of grow this database as needed, right? Anyone who's ever tried to do a spreadsheet as a traditional database knows you need to really plan out what are the rows, what are the columns, what does a database look like? In this way, we can actually grow the database in a very wiki way to say, we only know some things about the author, we only know some things about the painting, or some things about the artist, and we can just kind of grow it as we know it. And that's kind of the nice thing about Wikidata. So sometimes these are also referred to as graph databases, which you can see from here why that's called a graph database. There's a lot of power now in storing data in this format. And the reason why Wikidata has become so popular, now at 100 million items. So we crossed this just recently, and it's pretty astounding. I think in our conversation with Denny earlier, he was even like, wow, 100 million items. We didn't think we'd be here so fast. But yes, 100 million items are in Wikidata. And the nice thing about this is once you have that data in these triples, in this graph format, now you can actually create Wikipedia-like content from that Wikidata. Now, Denny just gave a whole talk about how, this new project called WikiFunctions can go even further, but at least with the very basic Wikidata content, you can generate something that looks like this. So Carla Hayden is the head of the Library of Congress, but just with the data that we have about her, we can write something that looks like kind of a first grade version of an article. Like, she was born on August 10th, 1952 in Tallahassee. She studied at the University of Chicago. She is a librarian. So very simple declarative sentences, but you can start to see the value of these things in Wikidata, meaning we can do all kinds of interesting things with knowledge broken into these little pieces. Right? So what are some of these things? Well, for example, we can actually ask questions of Wikidata. This is what we call a query. And what we can do is set up a triple and say, I don't know what's in the first position. I want to see all instances of bicameral legislatures. So everyone knows, hopefully, that our US Congress is a bicameral legislature. It has 2 different parts, right? But we can actually ask Wikidata saying, legislature, like show us all the legislatures that are an instance of bicameral legislature. And we actually have this query service for Wikidata, meaning you can ask it a question. Now, you don't have to know the exact coding of how to do this, but you can see it's not super hard here. We basically say legislature, and then we say we want to see all of them that look like this. And you can see that of those 100 million items, it can return us all the results in 271 milliseconds, which is pretty good, right? So we have 206 results coming back in like a quarter of a second. If you told me this 10, 15 years ago that we could query 100 million facts and come back with the answer in less than a second, I wouldn't believe you. But that's actually what we do all the time, lots of times per second on Wikidata. So this is the Wikidata query service, which uses a language called Sparkle. And I believe Min is going to talk about his experiences with Sparkle later in our conversation. So the cool thing is, if you make a query Wikidata and you bring back information, not only like what is it called, but you can store images, you can store geolocation, you can store dates. Once these things come back in the kind of table of the query, you have lots of interesting display options. So by default in the Wikidata query, we have the ability to show a line chart, a bar chart, a graph, a map, which is probably interesting to folks here from OSM. So the cool thing is one query, and you can try it out here if you want with the w.wiki/5vz, one query that brings back tons of information, you can actually display it as a map. You could display it as a timeline. You could display it as an image gallery. So in this particular instance, it is a query that says, show me all museums within, I think it's a 50-mile radius of the White House in Washington, D.C. And when that data comes back, it has pulled in images, it's pulled in, when the museum was established. It's even pulled in visitor numbers, like how many visitors per year. And you can see that just by clicking on a view, you can either see it in table format, as an image gallery, or as a bubble chart showing which are the most popular museums in DC. So this is really cool, meaning that one query allows you multiple views to interpret that data coming back. And that's the real power, ultimately, of Wikidata once you have a query language like this. So what are some of the challenges for Wikidata going forward? So that's kind of the five-minute tour. There are many challenges, but I thought maybe 3 that we could talk about today or discuss with the folks. One is modeling. So I kind of glossed over the fact that not everyone models painters and books and everything the same. So it's not always one big, happy, unified family, right? So recording knowledge consistently in a logical schema, not always easy, right? And we actually have something called shape expressions that's being developed to make that maybe easier in the future. Should Wikidata have 100 million items, right? So as we're celebrating 100 million items, some people say, oh, you're doing it wrong. You shouldn't have one big database. You should have many smaller federated databases, right? And that's probably the original vision of the semantic web that we're kind of not following, right? Should we split it off into a database of citations, a database of taxons, a database of other things? And then finally, performance. So 100 million items, we're doing pretty good, but it's kind of shaking at the seams in terms of the Blaze Graph software in the back end being able to service all the things that are happening. And there's a team right now looking for a modern open source alternative to this. It's not easy. There's not a lot of open source alternatives out there. So that's the basic scene that we have right now with Wikidata. So I'd love to hear from other folks in the panel about some of your views on this, but I'd love to call in Phoebe first. Since Phoebe, you are kind of one of our, original users of Wikidata in the library world, and yeah, love to hear your views on things. And I will let you share your screen too, so you can show us some cool stuff.
Great, thank you. And I believe Denny is here as well, Andrew.
Oh, great.
His internet was down and then back up again. So,
Welcome.
it's funny with Denny here asking me to talk about Wikidata. I have never been a Wikidata expert, but I have followed it from the very, very beginning. And I was digging through my email thinking about the 10th birthday and came across this talk I gave to a library organization before the official launch date of Wikidata, where I was talking about how exciting it was that Wikimedia Germany was building this project, and maybe someday we could link to data that was in library catalogs, right? And we have done that. So that's very exciting. But I also remember thinking about the history of Wikidata and the 10 years that it's been in existence. I was often, and to this day still am often, excited about it and also confused by it. Often, I can tell that it's exciting, all these things are happening, and I often don't know exactly what's going on. But I'm not the only one who was excited about Wikidata. I think it's our most edited project now, and it is our project that, like Lydia said, has really brought us together. Or Leia said that it has really brought us together as a movement, and I think it has. And for a lot of us who have been involved in Wikipedia for a long, long time, Wikidata has felt like the exciting early days of Wikipedia, where it's very dynamic and there's all these things happening and all these things developing and tools and new projects and new ways to get involved. So I've been thinking, Andrew, about why Wikidata is like that, why it's dynamic, like why has it proved to be this dynamic creation? And so I thought we could think about the features of Wikidata that have made it this most exciting, and most edited project. So this is very basic, but you asked us as a prompt what our favorite project on Wikidata was. And my favorite project is not a project. My favorite project is the property proposal process, which I know everyone hates, and it's very cumbersome and it's really hard to work with. But think about how cool this is. You can go in and propose that we add something else to the database of human knowledge, that the graph will have a new feature. And people have done this thousands and thousands of times. And although it's clunky on the back end, I know it's actually pretty easy to propose a new proposal, a new property, and everyone, is nice about it typically too. So I have 10 things. This is thing number 1 that I think make Wikidata really exciting. Do you want to ask our other panelists, or should I go on with the rest of the list?
Well, you can go on for a few things on the list, and then we'll move on. Go ahead.
Sure. So property proposals. That's my first thing that is really fundamental to why Wikidata is a dynamic community project. And those of you who I've talked to know that I think a lot about how to make our communities vibrant and stable and sustainable. And the second thing that I think has really contributed to Wikidata's fundamental growth and success is the fact that it's structured, but not just that it's structured, that the UI is structured. That when you go in to edit without running any tools or anything crazy, you get a field where you can only do a few things, which is very different from Wikipedia, where you can type anything in and it's confusing to know how to get started. And so it's very simple to make a new thing but you're bounded, right? And so it's easier to tell people how to do it. I've taught a lot of people how to edit Wikidata, and it's much simpler than telling them, like Ian was describing in the previous session about WikiEDU, how to write an article from scratch and bring in all these editorial conventions and whatnot. I think another pillar that really underlies Wikidata, and again, those of us who use it know this, but it's not immediately obvious. The fact that not only can you query it, but there's this interface to query it. But I would argue the real secret sauce here is being able to ask for help, right? I have never learned Sparkle very well. This is my confession to all of WikiConference North America. I am a basic Sparkle editor, but I can ask for help, and there's all these lovely examples, and people will write queries for you, and that makes it so much more accessible than other similar tools.
And you can also request it on Twitter as well, right? We actually have folks who do queries on Wikidata via Twitter requests as well, which is really cool.
So these things that we totally take for granted about Wikidata have made it this project that you can use without actually knowing very much about the database at all, or knowing Sparkle, or knowing any of it. And so it has really led to this global project, right? And I think that's just incredible. So yes, I'll stop there, and I have a few more things that I think have really led to our 10 years of growth here. But I'll let others speak to that. Yeah.
Thank you so much. Yeah, there was comments in the chat about, editathons using Wikidata because it's on Rails, as you said. It actually can be a lot more satisfying for newbies, which is great to see. I thought we could have next, Richard can talk a little bit about the really cool project he's working on in terms of open historical map and the relation with Wikidata. So Richard, please.
Yeah, I see you've got the statement I made yesterday in email up there. So that really covers the gist of it. I'm a relative latecomer to Wikidata. I really first started thinking about it, it might have been as much as a year ago when Min proposed it as a tool that we might use bridging between OpenStreetMap and Open Historical Map. My original reaction was very conservative because I didn't know Wikidata. It was like, well, yeah, but we would be depending on something external that we don't have control over. And as I have come to understand Wikidata, my view has pivoted, and now I am interested and really excited, to be truthful, about the possibility of leveraging Wikidata as wiring all kinds of open data projects together, not just the connection between OpenStreetMap and Open Historical Map, which is an important one, and we don't have a way to do that right now. But we've already done a little work wiring Wikipedia articles into Open Historical Map. When the link is set up, the article text pops up. And if links into Wikimedia Commons are set up, images pop up. But that doesn't use Wikidata yet. That's still pretty much ad hoc stuff. And I can see a major expansion in capabilities if we can leverage Wikidata to get to the full suite of linked information. And it can be used in both directions. Last night, I saw a really nice Wikipedia page I didn't know existed on the shoreline changes in Lower Manhattan from the beginning of the Dutch settlement through the modern era. And it's a nice web page. It's got a lot of good data on it. It's well researched. First-rate job. But I happen to have spent some time making a historical map, an open historical map of the shoreline changes off of old maps. And I have an animation of it in Open Historical Map, and that is a thing that could be embedded on the Wikipedia page if the mechanisms were there to do it. And I don't know how to screen share here. Okay. Okay, what I want you to do is go to Lower Manhattan.
Okay, go to Lower Manhattan.
Because I don't think I can manipulate this. So zoom in a bit and lower. Good. Now, in the time slider, and this is a feature we've only had for about 2 years. No, you don't want to do that. You want to go up to the boxes up top, and you want to go to the leftmost set, and you want to change the year box to 1600.
Whoa.
And go click set on the right side. And then position that.
Wow.
Keep going all the way to the beginning.
Wow.
And then go click the play button in the bottom. This is going at 10-year intervals. So it's covering the Dutch settlement and then the British takeover and then colonial and early American times.
Nice.
And so you can see that it's starting to creep out. And then economics come into play. And that's the first wave of docs. And there's a second wave of docs.
Neat.
And so we've got this. And there's no reason why it shouldn't be possible for that to be embedded in a Wikipedia page if we just build the mechanisms.
Right. Right.
And I just put a ticket in the system 5 minutes ago while I was off screen saying, why don't we have this yet in Open Historical Map? Why can't we embed this?
I think there's a lot of questions in Wikipedia, like why can't we embed X, where X is a pretty long list of things, and we have a weird culture of being a little bit resistant to that. So maybe Min, this is a good time for you to jump in since you have experience on both sides and as a developer. Like, what is the culture not only of being able to do this in Wikipedia, but also vice versa, like bringing wiki content into the OpenStreetMap community?
Yeah, exactly. You might, I think you both alluded to sort of like the initial resistance that people kind of run into when faced with an open, clearly open project, aligned in some ways, but it's just it's a huge realm of like overload of information that you don't understand. And so that's a big challenge for all of us to kind of help each other understand these projects better. You know, Wikipedia has in the past, had had folks resisting, maybe other kinds of multimedia coming inside the article. And over the years, there's also been a lot of discussions in the OSM community about whether or not to even link OSM features to Wikidata in either direction. And if you're curious, I've put together a kind of a bibliography of some of those discussions. I don't recommend reading it tonight. It's just going to put you to sleep. But there's, I think the most interesting takeaway for me is that despite all the initial resistance that we got, especially from some of the communities in Europe that were already very tightly integrating OSM and Wikipedia, they weren't as comfortable with Wikidata at first. But what really changed the conversation was when they were able to see concretely the applications, the things that people were able to do and answer with all this linking. So, for example, when the community in, I think it was Belgium, created Wikidata items about all the streets in Belgium, and then linked all the streets in OpenStreetMap to those items, and added named after items to all those streets. And then you can come up with like maps of the streets that are named after scientists or women or all kinds of other questions. And being able to see that and see that, well, there's no other way to do this but to link, really changed the conversation. And then it's not just in Belgium, it really just spread by like wildfire. And so I'd like for there to be more opportunities for that to show people what's possible with visualizations like that. And you showed off Wikidata Query Service. It's one of many Sparkle endpoints. There's actually a lot of them out there. I keep on discovering more of them. I know of at least two that store OpenStreetMap data, and one of them federates with Wikidata. It's called Sofox, but it needs some love. It needs some maintainers, and maybe needs some new hardware as well. So I think this is an opportunity for us to really show that. Oh, sorry, Netherlands, not Belgium. I think it's an opportunity for us to show on the Wikidata side, what the promise is of Wikidata, and on the OSM side to show what the promise is of OSM. And I hope that we won't even have to have this conversation a few years down the line. It will just be evident to everybody because of this is what you'll be presented with the moment you join one of these communities, that it is part of the larger ecosystem.
Right. Great, thank you. I think there's going to be a common theme, especially with my little pet idea as well, is that the more it makes sense for folks to modularize and incorporate things back and forth into projects, the more you realize we don't actually have a deep history of doing that in Wikipedia. We're actually very conservative. We don't even use Wikidata to generate a list in an English Wikipedia article, much less take in an external project or an external JavaScript. So my little pet idea, which I wish we had more one-click mapping visualizations in Wikidata Query. So the one that we showed you before is that if you have a geo-coordinate, you can slap it onto a very basic map. But beyond that, you can't do much. And in fact, that list of visualizations, I believe, has not changed much over the last few years. Are we back? Sorry, I dropped out for a second. So we don't have a lot of options there. And something that we did recently, some of the folks here, we were on a team during a data challenges that come up with visualizations based on Wikidata. And we actually had to exit Wikidata Query to do interesting visualizations. Like we generated the data from a Wikidata query, but then we wound up using a tool like Kepler. So I don't know how many people use Kepler.gl. I think it's an open source library that the Uber people have contributed to GitHub. But look at this. I mean, it'd be so cool if we could generate visualizations like this straight out of Wikidata. But in fact, we had to dump it out in JSON and bring it into this other tool. Then it's not one click. But this is a really neat visualization we did for this datathon, which basically shows two endpoints that are connected with this arc. And basically all the ones that are in New Brunswick, which is that province in Canada, That's where people died. So these are all the notable people who died in New Brunswick. And then the other side of the link is where they were born. So it's kind of interesting, right? It kind of shows like where the immigration patterns were for all these notable folks. And what was interesting to us was that there's more connection between New Brunswick and Europe and Northern Europe than there is between New Brunswick and the other provinces of Canada, right? So it actually shows that Canada is a very interesting place in that even like provinces on two opposite sides of the country are not that strong in terms of bond. There's actually much more affinity in New Brunswick towards Europe. But wouldn't it be great if we had these 3D kind of visualizations we could hit with one button, and we just don't even have anything. We don't have a modular system. We don't have an extensible system. It wouldn't take much glue code to bring some of these GL libraries to be attached to the output of a Wikidata query. So I'd love to have more options to do something like that. And maybe this is a good time for Danny to jump in. I know, Danny, I see you chomping at the bit for like seeing all the things we're talking about. Like, yes, more of that, or maybe not as much. So, Danny, please do chime in. I'd love to hear your views on anything that we talked about so far.
You know, totally moved all of this. I really loved the demo that Richard showed. It was like, this was mind-blowingly cool. And I love this visualization with that you get from Kepler and so on. And totally, this is stuff that I would love to see as well in the Sparkle endpoint, immediately getting out of it. I don't think there is too much of technical issues to do that. Someone has to go to do it, assuming the licenses are working out and so on. So I was thinking about the prompt that you said, like what really amazes about Wikidata. And I mean, this on the technical side, the thing that really amazes me is the Sparkle endpoint. This is the one thing that I didn't believe in the beginning could exist, because there was no triple store that was able to deal with the needs of Wikidata. And I was proven wrong, and very happily proven wrong, and it became a completely centrally required tool. Now we're getting at a point where it's again causing troubles because we are pushing at the limitations of what open source triple-N stores can do. But well, that's a problem we have to. But I'd rather have this problem, the opposite problem of not having enough data or not having enough people contributing it to actually push the triple store to its limits. So I'm very, very happy with where we are with that, and that it actually did work out. So this is on the technical side, the thing that really amazed me and surprised me about Wikidata. On the other side, the main thing is really the community, which I just can't praise enough for what they achieved, and all the members of the community. From the very beginning, the community was very understanding of like the state of the UI when things didn't work, when we were saying, yeah, could you please slow down your bots? People would just go and slow down the bots. It was always a very collaborative relationship with the community, something that I don't see often repeated within the Wikimedia communities and with the teams working on the projects. So I think this is really a beautiful, positive example of how a community and a project team can work together. And I'm really amazed by that. And the other thing is that every time I bet on the community to get something done, I was fortunately right, and they not only fulfilled my expectations, but like completely over fulfilled them. So one thing that I remember is when we started Wikidata was that a lot of people were saying, oh, we should have a fixed ontology in Wikidata, and the data should be like structured in certain ways. I was saying, no. Let's trust the community to build the structures, because seriously, none of us is smart enough to come up with a fixed ontology for the world. And not even the team is smart enough for that. It has to be in the hand of the community to do that. And they did. And they created this incredibly amazing resource. I don't think we would be where we are now if we would have a fixed schema from the beginning. But it had to be this way that the community can actually control it and can extend it. And I'm super, super happy that the betting on the community works out so far every time. And I plan to continue that one. So yeah, I think those are the things that really most surprised me.
Thanks, Denny. I forgot to mention that you had a nice think piece on the 10-year anniversary. I don't know if you've published it somewhere open. I know it was on Facebook, but I think you'd use the phrase like it is the visualization options for Wikidata are criminally underused. So I think that definitely fits the theme of what we're talking about here of once we see the animations and once we see the visualizations are possible, this is a whole other dimension we haven't really explored deeply recently, right?
Yes, fully agree. Yeah.
Richard, Phoebe, Min, any feedback after we're considering some of the ways to integrate the two worlds of OSM and Wikimedia more?
I see the chat box lighting up with ideas of new visualizations and animations, and I have to say we're on the cusp of making that all possible. We just need some of that front end work to really expose all the hard work that the community's been doing on the data side, on both Wikidata, on OpenStreetMap, on the historical map.
Yeah, and I think I want to make an observation that, communities can be slow to move. You've made observations about how Wikipedia is slow to move. OpenStreetMap can be the same way because it's been around for more than 10 years and people are set in their ways. Open Historical Map, and I can say this with vague authoritative status because I'm a member of the advisory board, we're still very experimental. We have some constraints we're under, but both Jeff, the other member of the advisory board, and I have extremely light hands. We encourage experimentation because we admit, even though we've been doing this for approaching 10 years, in many ways, we still don't know what we're doing. And so don't let trick animations fool you. There is stuff we are still learning. And so, if you're looking for an experimental laboratory to collaborate with, we're up for it. I also wanted to refer to a comment I saw Tanya H. make earlier about geographical battlefield stuff. As an amateur historian, the data availability will be challenging, not impossible depending on the battle, but challenging. But I am, in fact, experimenting with putting historical event data on the Battle of Antietam into the map with an eye towards animating movements of troop units as low level as regiments across the battlefield on a half-hour to hourly basis. I'm not sure where that's going to go, but this is the sort of thing that's possible, except we're not sure how to do it yet.
So, Andrew, one thought that I had about, one of the many things that makes Wikidata accessible and interesting and to a wide number of people is that it is both very, very global and also very, very local. And so, there's this feature nearby in the main Wikidata interface now where you can see the articles that are, or the Wikidata items rather, that are near you. And this is tied to like our geo coordinates and things like WikiShootMe and all these other projects to get in this hyper local data. I can show it in my screen if you bring that up, or you've got it there too. And I think something like this has a ton of implications for both like data layers. Like, let's show, the books that were written by authors from my town. Let's show, the provenance of art. Let's show cool buildings. But it also offers a way in for outreach purposes. People are interested in what's around them. People are interested in the things that are near to them and nearby and part of their world and part of their communities. And so I think any of these visualizations that we can bring in to either, hook into collections or hook into people's current lives and local communities are going to be really powerful for bringing in new editors too.
Yeah.
Go ahead.
No, go ahead, Min.
From the OSM side, we actually do have a source of new editors for Wikidata also. there's this kind of branch of the OSM project called the Name Suggestion Index, which is just cataloging brands so that it makes it easier for people to map stores that are part of a chain. So say like a McDonald's location. And in order to do that, it relies on Wikidata for cataloging, for uniquely identifying each of those chains. And what seems to be driving a lot of the contributions is people are just wanting to be able to see that logo for that brand in the list of things you can map. And so it just makes me wonder how much more of an effect that would have if there were some alternative rendered version of the OSM map that showed little brand icons on all over the map where there's those stores. Would be the furthest thing from the kind of humanities that we talk about with Wikidata very often, but it's something that's already driving a lot of contributions to Wikidata.
Yeah, that's a great point, and something that came up in the discussion before in terms of having imagery and maps. Like right now, the very primitive interface that you get from Wikidata queries, you can show dots on a map, but nothing beyond that, really. You have really no way to customize the views of images or anything else on the map. So there's a lot to be desired there. I think Daniel Meechin even said you can't even do a logarithmic scale on a line chart. So that's pretty bad that we don't even have that basic capability.
But I mean, by the same token, though, I have never been to a Wikidata event of any kind, a talk, a session, a conference, without people saying, "Hey, do you know about this cool tool?" And somebody saying, "No, I had no idea this tool is amazing." Like without fail, right? There are needed tools, and there's also this existing enormous pool of tools and games and projects and scripts, and so I think one of our challenges actually is getting these like specialized tools into the hands of people who could use them with their data and their projects and training, because it's not it's very simple, I think, to get started with Wikidata at the most basic level, like to make an item. It's actually very complicated to do the kinds of things we're all talking about here with like using tools and queries and visualization. So like, what's the bridge there? I think about that a lot.
The discussion on the chat is also going a lot about like how funding would work. And this ties in with what just was Rafid mentioned. I think one of the strengths of Wikidata is that yes, we have this core development team. We have the people working on the Sparkle endpoint. They need funding, obviously, but they quite get funding. You can do a lot of things by funding outside teams. You don't have to be in the core team. You don't have to change the core of Wikidata, of Wikibase, in order to get a lot of things done. So you can have fundings with a local museum or with a GLAM organization and so on, and all these things in order to get more collaboration going on, in order to get more things working. And this can be done by local chapters of the movement. This can be done by third parties and so on. And for these, obviously, I mean, the possibilities for funding this kind of project is basically endless, because there's so many GLAM institutions out there which will benefit from that and can be connected stronger with the Wikidata community and so on. So it doesn't, when we think funding, it doesn't have to necessarily be like, we need to fund the developers in Berlin. But a lot of these actually should go really to the community, should go to projects done with third parties, and to work together with them in order to tie these things together. It could be for setting up a different Wikibase instance, for example, which would be like a major project. It could be just like to extend for one specific museum how data can be published and validated that it's being in Wikidata and so on. All of these would be very helpful for Wikidata in general and also for the world.
Yeah, and Jenny, some of that too is it's really a philosophical problem, right? WikiCite is the example that I've been the most involved with, which is the project that is sort of an umbrella project to work on bibliographic metadata, items about books, journals, articles, sources, right? Articles about sources that we can use in the Wikimedia projects and beyond. So there's been a lot of talk about maybe making that a federated database for technical and also social reasons, but but do we do it or not? Like, how do we come to that consensus? That's where, we've had a lot of discussions over the years. And I think, there's versions of that in a lot of domains. So that is to address the chat, sort of possibly a funding problem, but first you have to decide what to fund, right? And how to get there.
Yeah, and we're in the last 10 minutes, but great conversations. Definitely keep typing in the chat. We can bring your comments up on screen, and we love talking about those things. Something we didn't mention at all, but we probably should mention, is that Wikimedia Commons now has Wikidata-like functions, right, with the Structured Data on Commons project. So if you haven't noticed, when you look at a page on Wikimedia Commons for an image, there's now a structured data tab that you can actually add the same type of things you're used to seeing on a Wikidata item to that Wikimedia Commons file. And you have the same type of query capabilities. So you can do a Wiki Commons query search. But this is something can't remember if I brought up with you, Danny, but I'd love to get your and all the folks' feedback on. Is one of the complications right now is because of scalability problems and Blazecraft, like the Wiki Commons query service is now authenticated, right? You can't just hit it unlogged in. You have to be logged in. And it's reasonable to, given their reasons for, scale and quality of service for that type of offering. But it does bring up the question of query is always seen as kind of a support function for the normal operation of Wikipedia or maybe Commons. But in fact, Wikidata query, Wiki Commons query, that is now, I think, Danny, you hit on this, like the primary way you experience this content now. It's no longer ancillary and to the side. It is the main way. And it reminds me of, in the early days of the internet, Sun Microsystems, one of the original companies that did, computing, had this saying, which is really weird at the time, but it's completely true. They had this saying that said, the network is the computer. And at the time, people were like, what are you talking about? The network is not a computer, the network is a network. But now with cloud computing, right, with AWS and things out in the internet, this whole saying of the network is the computer is absolutely true. Similarly, I think we might have a saying in our own community, like the query is the content. Like the query is not the support function that eventually like the query itself is the content. And that might center us better into we need to upgrade that query experience, making it modular, extensible, that we can graft Kepler onto it. We can have a logarithmic scale for Daniel Meachin. We can upgrade this because it's the primary interface now. And I don't think we've been thinking about it as the primary interface. So I'm wondering whether Min or Denny, since you're kind of in the weeds of the development side, have we appropriately thought of the query as the meat of the sandwich and not just the bread of the sandwich, if we want to use another metaphor?
I think you're absolutely right about this. A couple of years ago, in response to the George Floyd protests, a local community of OSM mappers that I'm part of, we put together, we kind of took that approach I mentioned of mapping out what streets are named after what, and visualizing that, visualizing namesakes of Confederates, visualizing, places named after, segregationists, stuff like that. And we put this on we basically hooked it up to, at the time, I think it was SoFox, but same thing. It was just like Wikidata query service, right? It's a very basic map, and it was great until the point where someone asked me, do you have a link I can share on Twitter? And then all the people going to this really raw, Wikidata query service interface, right? That's not the greatest experience. So yeah, some kind of front end would be really, really nice.
Oh, and Denny, I think his bandwidth dropped. I'd love to hear his feedback on it, but it looks like we had some comments here as well. It does sound like a little bit like Marshall McLuhan's "The medium is the message," or we actually do have namespaces that fit this description, right?
And that's funny, man. So I worked on the Wikipedia article side of documenting the protests, and at one point we made a very large and unwieldy map that was again abusing the template system and everything else, and it that would have been perfect for actually doing on something like OSM, I don't know, layer, something more suited to mapping, right? I'm just not sure anyone working on those articles knew how. So again, it's this like knowledge problem and tooling, but also sharing tooling problem.
Yeah, exactly.
Yeah.
Great.
Maybe we need more than 1 hour if we get these folks in the same room.
Yeah, I think, just to go back to what Denny said in the previous talk is that, the idea of WikiFunctions is to give you capabilities that no one has ever seen before, right, with WikiFunctions. Same thing with Wikidata Query is to create a narrative or story or weave together a story that no one's ever thought of before. And that's the beauty of Wikidata Query, right? I can show you a map that no one ever thought of to connect these concepts before, right? So Danny, I'm wondering if you had any feedback on the queries, the content idea.
The original idea of Wikidata had always so-called phase-free, where we would have a query namespace. It was mentioned in the chat right now, where the query would actually be stored and where it would be then available to also transclude it into the Wikipedias and so on. And the idea with the query namespace, we would also like have a forcing function on the structure in Wikidata, make it more consistent, make it more uniform and so on. This never happened, but it was always understood that watching individual statements of an individual item isn't really the cool part about Wikidata. The cool part is as soon as you put it into a query and see the display. It's like if you would look at OpenStreetMap and just look at the number of coordinates, that's not so interesting like it is to see actually the tiles being served and like the graphs being and the paths being done and so on. So yeah, phase-free never happened. So WikiFunctions is indeed, as was mentioned by Jan just right now, is indeed meant to kind of be something like a hidden phase-free, that we can take in the content from Wikidata and have a function run over it, create some output, which then can be used in the Wikipedias. And this would basically be then the way how to make the content from Wikidata more visible. Because what I really believe is that data is only good when it's being used. Only when it's being used, it's being checked for correctness, it's being updated, it will get made comprehensive over the and with coverage. If we don't use the data, it's just a pain to have it around and just a cost factor really. But when we use it through queries, displaying it in places, this is really what makes the whole magic happen.
Right. We're coming up on the last minute or two, but I wanted to thank everyone. This has been such a great conversation, and thank you so much, Denny. We are privileged to have the creator of Wikidata to help us celebrate Wikidata at 10. This type of exchange between OSM folks and the Wikimedians is exactly what we've always wanted out of this WikiConference North America in terms of bringing together folks who are clearly like-minded. We've never had that opportunity to exchange, and this is just such a great experience to see that. Min, you want to have some closing words for us? You've been one of the main organizers of this conference, so thanks so much for putting this together.
Yeah, thank you for leading the session. So as we close out this conference, I just want to say thank you so much to everyone who helped make this conference a success. And I think it really was a success. This time last year, the team behind WikiConference North America was feeling really burnt out after putting on a conference. I don't know if everyone knows here how much work goes into putting on an online conference. It's not the mini version, it's not the light version of putting on an in-person conference. There's so much to deal with. And especially with a volunteer community, it's hard to muster up the energy to put on yet another one next year. So we started conversations about like what could happen if we team up, and who could we team up with, and it seemed pretty natural, in my opinion, maybe I'm biased, that we would at least try this partnership, try this out and see what would happen. And I'm really glad we were able to pull this off. And I hope it's just the start of the conversation for everybody. I'm sure you've seen things here at this conference that you've never heard of before. I certainly have. And please do check it out. And now you know about some of the people behind these projects as well. So you have people to help guide you in that exploration. So I guess apart from so thank you everyone for attending. We do still have wiki related events tomorrow. So I guess Andrew, maybe you can speak to that a little bit.
I only know what we have on the schedule, so of course, everyone is welcome to come to those sessions tomorrow. But thanks for making today such an amazing exchange of ideas. I know I have like 3 or 4 ideas already for new projects in my head, which is always a problem in terms of attention span. But again, thank you, Richard, Denny, Phoebe, Min, for making this a great conversation, and all the folks who left comments there. Have a great rest of your day, and hope to see some of you tomorrow.